Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at the full, full question paper of May, June 2025. Okay, I'm gonna be honest with you guys. I don't know if you are. I think you will be writing prelims soon. Yeah, and I decided to say, okay, you know what? Let me just write this question paper, and maybe some examiners in your respective respective provinces will try to have some few questions that are similar to these ones that was written in May, June. Okay, the question itself, the question paper itself is intimidating, guys. As you know, the memorandum is not yet out as of yet. So I was like, okay, let me try it. Okay, so yeah, I'm scared, but let's dive into it. Cool. So solve for x. The first, I know these ones should be fairly nice. 1.1.1 says x squared minus 3x minus 10 is equal to 0. I'm solving for x. I know factors of 10 in such a way when I subtract them, they give me 3. It is 5, and 5 should be a bigger number, and 2. And then I have x, it is equal to 5, or x, it is equal to negative 2. Okay, this one is really beautiful. And then let's move on to the second one. 3x squared plus 6x plus 1, it is equal to 0. Correct to 2 decimal. They automatically tell me I need to use what? Quadratic formula. So quadratic formula, I don't like writing it, but I'll write it negative b plus or minus b squared minus 4ac like that, divided by 2a. Then x, it is equal to negative, what is b? b is 6 plus or minus 6 squared minus 4a. A, it is 3. C, it is positive 1. My a, it is 3 again. And then I have x, it is equal to x, it is equal to negative b plus or minus, you go, negative b plus or minus, guys, what's happening? Plus or minus b squared minus 4a is 3, c is 1, divided by 2 times 6. Hopefully I did not make any mistake, guys. I get negative 0.09, or x, it is equal to negative 0.91. Guys, is it true? Negative b plus or minus square root of b squared minus 4a 3c. Okay, guys, hopefully it's correct. Hopefully it's correct. So moving on, it says now I have this one, 2 to the power of x plus 4 plus 2 to the power of x minus this one. How can I do this? I don't know. I'm thinking quadratic. Why quadratic? Okay, I'm thinking, how about I do this? Remember, let's apply laws of exponents. Let me minimize. I have 2 to the power of x multiplied by 2 to the power of 4 plus 2 to the power of x. It is equal to 8704. And then I can take out, since, well, this is one term and this is another term, I can take out the highest common factor of 2 to the power of x. It's going to be 2 to the power of 4 plus 1, which it is equal to 8704. 2 to the power of x is going to be equal to 8704 divided by 2 to the power of 4 plus 1, which I think is 17. I get 512. How can I express 512 in terms of its base? Or in terms of base of 2, I'm going to say 512 equal sign shift factor. I get 2 to the power of 9. And then, therefore, x it is equal to 9. Guys, you can use logs here and say x it is equal to, I drop it, I need to say log base is 2 to the power of 512. Let's see, log base 2 to the power of 512. Yeah, you get 9, guys. It's still the same thing. Okay, I move on. I have this question here. X minus 8, x plus 2 is less or equal to 0. My critical values is -2 and what? And +8. Then I can draw my thing here and say -2 and 8. I need to see if it is a parabola facing upwards or downwards. I need only the coefficient of x squared. X multiplied by x, it is x squared, so it is positive. So it's going to be facing upwards with a smiling like this. I like to say it is a smiling face. Okay, and we want where it is less or equal to 0. So less or equal to 0, it is this portion. I get. So I'm going to say, therefore, x is between 8 and -2. I prefer writing like this. X is an element of -2 and 8. Either of the answers are correct. Okay. Some of you use this method. Let's check. Let me put a value between -2 and 8 and put it here and see if it gives me a positive or a negative. And say when I put 0 here, let me put 0. When I put 0 and 0, it's going to be -8. Let me draw another one for you. Some of you do it like this and it's still fine. When I put a number between -2 and 8, I choose 0. It's going to be -8 multiplied by +2, which is negative. And then any number above 8, I'm just going to choose 10. 10 minus 8 is going to be 2, multiplied by 12 is positive. And then here it's going to be positive. Let me choose I'll choose what? -3. When I put -3, it's going to be -3 minus this one, -11. -3 plus 2, it's -1, and then it's positive. And you know that less than 0 means negative. So it means it is from this one to that one. And it's very important that it is not like this, but rather shaded. Why? Due to the equal sign. So it's still fine. It's still fine. I hope it is understood. And let's move on to the next one again. It says, let me erase this so that I can see clearly what I'm working with. It says, 1.1.5. Can I do 1.1.5 here? I think so. The first thing that I'm going to do here, it is isolate the square root to make sure that do not try to divide by 3. Okay, just take this x to the other side. It's going to be 3 square root of x plus 2. It is equal to 2, right? And 2 minus x. And then what you're going to do not divide by 2, guys. Please don't do that. It's going to cause you a lot of problems. You can, but you should be good with the mathematics, so don't. So just square this. And then square the other one. When you square, it's going to be 3 squared, guys. 3 squared. 3 squared is going to be 9. And then this one, square root of x plus 2 squared, is going to be just x plus 2. You put a bracket like that. Okay? It is equal to 2 squared. It's going to be 4. 2 multiplied by negative x multiplied by this one is negative 4x. Negative x squared is going to be plus x squared. And then I can become a mathematician and say this is 9x plus 18. 4 minus 4x plus x squared. Then take everything to the side with a more x squared. So I'm going to have x squared, negative 4 minus 9. It is negative 13x. 4 minus 18. It is minus 14. is equal to 0. Okay. Let me say it is equal to 0 like this. And then factors of 14 such a way when I subtract them, they give me 13. So it's going to be 14 in 1. X minus 14, x plus 1. It is equal to 0. And then I'm going to have x, it is equal to 14, or x, it is equal to -1. But what's really important is you coming back to this one and just confirm if your answer is the same now. Let's first substitute x as 14 and see if it satisfies the condition. 14 plus 3 into 14 plus 2, and check if it is like that. So I'm gonna have 14 plus, okay, this one is already, it's not working. This one already is not working. Why? Because it's gonna be 14 plus 3 into square root of 16, it's 4, and this is something like 2. So automatically this one cannot equal to 2. So I have 12, this is 26, is equal to 2. They are not equal, it's a contradiction. So it cannot equal to 14. Okay, let's confirm using 1. When I substitute x as 1 and 1, it's going to be 1 plus 3. Did I make any mistake? Because there's no way that, oh, it's -1. Here, -1. -1 plus 3 into -1 plus 2, it is 1, just 1, equal to 2. And then it's -1 plus 3 equal to 2, it's 2 is equal to 2. It's fine. Therefore, I like to say, therefore, x is equal to -1 only. But it's fine because you have already cancelled this one, okay? Cool. Let's move on to interesting stuff. A different simultaneous question that you have never seen. Okay, you have, but not in question 1. Another thing, guys, if you're doing metric now, I'm not saying this in a bad way or what, but I'm talking from an experience, considering the fact that I've looked at more than, I don't know how many question papers that were that was written by those who were rewriting. Guys, the examiners in June, May, June, when you are writing, they can be so, hey, I don't know. It's like they are trying to remind themselves of their, I don't know, uh, university life or whatever. Like, I don't know what's happening with those guys. In May, June, let's continue, guys, before I get into trouble. It says, a rectangle having side of this 1 meters and x plus 2 meters has a perimeter of 24 meters and an area of 32 square meters. Area, okay. Calculate the value of x and y. Okay, this is not difficult, guys. Just make sense of this. If I'm having a rectangle like that, it's not that difficult, but people will see it as difficult. So having sides, this one and this one, they did not tell me which one is the breadth, which one is the height, length. So I'll just say this is y minus 3 x plus 2. Okay, you can say this is the x because it's horizontal, this one height. It's the same thing. What I'm told is that the perimeter is equal to 24. Ask yourself, what is the perimeter? The perimeter is the total length of the side, this plus that plus that. So if I were to do that, do you agree that this side and this side are equal and this side and this side are equal? So for the perimeter is going to be 2 because this side and this side are equal. So it's going to be 2 the length, which is y minus 3, plus 2 the length x plus 1, like that. 2x plus 2. Guys, what you can do, you can say, okay, this is also x plus 2. This is also y minus 3. And add this one plus this one plus this one plus this one. It's really the same process, guys. Trust me, it is. Do not become intimidated by what I'm doing. And then the perimeter gives me something like, when I simplify it, 2y minus 6 plus 2x plus 4. And then I can say it is 2y plus 2x minus 2. 2y plus 2x minus 2. Okay, that's the perimeter, guys. And then I'm also told that the area, it is equal to what? It is equal to what? Oh, this one squared, right? So you know that the area is going to be the length multiplied by the breadth. So what is the length multiplied by breadth? It's going to be y minus 3 multiplied by x plus 2. And then when I simplify that, I get something like xy plus 2y minus 3x minus 6. Okay, this one I'm told already is equal to how much? Oh, guys, also this one I was told already is equal to, okay, let me do this because I am realizing that this does not necessarily give me simultaneous, but it will. Okay, let's do this. Let's give it space. Okay, so, but now I know that perimeter, but I'm also given that the perimeter is equal to 24 meters. So I can say, oh, it means now 2y plus 2x minus 2, it is equal to how much? 24. Okay, so if that's the case, it means now my 2y plus 2x, it is equal to how much? Check, when I take the 2 to the other side, it's going to be 26 again. So I'm going to say it is equal to 26. And I can simplify this any further and say, okay, let me put it like this. Y plus x, it is equal to 13 when I have divided by 2. You can literally do that, guys. It's still fine, or you can continue with this. Let's call this equation 1. And then my area it's given to me as 32 what squared here in your again. And then it's going to be xy plus 2y minus 3x minus 6. I cannot do anything. Okay, I can equate it to 0 and say, therefore my equation is going to be, so 0 is equal to, let me say, xy plus 2y minus 3x. And then when I take 32 to the other side, it's going to be negative 38. It is equal to 0. Let this become my equation 2. Okay, or here, guys, I can just make x a subject of a formula here. I can say, remember I said it is y plus x, it is equal to 13. Therefore, I can say, okay, therefore x is equal to 13 minus y. Let this become equation 1. And then what do? I tell the examiner that I substitute equation 1 into equation 2. Okay, the examiner is aware of what I'm going to do. So where I see x, I put what? 13 minus 1. So it's going to be 13 minus y multiplied by y. You can multiply it by y here, it's still fine. Plus 2y minus 3 into 13 minus y minus 38, guys. It is equal to 0. Let me quickly simplify that. It's going to be 13y minus y squared plus 2y minus 39 plus negative by negative, guys. Very important. It is positive. Plus 3y minus 38. It is equal to 0. Can I simplify this? I think I'm going to need space here before moving on to question 2. Insert page above. Guys, okay. And then I'm going to have negative y squared, 2y plus 3y. It will be plus 5y. And then, okay, plus 13y. 2y plus 3y plus 13y. It is just 18y instead. And then I have negative 39 minus 38. 39 multiplied by 2, it is 78. So it's going to be minus 77. Guys. Okay. It is equal to 0. And then I may take out the highest common factor here. I'm going to divide by negative so that you are aware. Divide by negative 1. So that I have y squared minus 18y plus 77. It is equal to 0. What are factors of 7 such that when I add them, they give me 18? So it's going to be 11 multiplied by 7. Again, when I add them, they give me 18. So it's going to be y minus 11, y minus 7. It is equal to 0. and y should be equal to 11, or y should be equal to 7. And then how do I get x? I get x by substituting it here. Remember, uh, remember I have the equation for x. Okay, I have that equation for x, so I can substitute there. So let's substitute 11. 13 minus 11, it is true. Or x, it is equal to minus 7, it is 6. Okay? 13 minus 7. I will go. 13 minus 5, it's 6. So guys, here are the combination of the values of x and y. Let's see if they make sense. It's either then, it means now, let me take this. Then it means now it's either I have this part, okay? Therefore, it's either I have this triangle with the length of, let me draw another one. The first combination can be, let's use the first combination, this one. When I use that first combination, it's going to be 11 minus 3, which is 8. And then 2 plus 2, it is 4. The second combination that I might come across when I use the other pair, it's going to be, this is 8, guys. 7 minus 3, it is 4. And then 6 plus 2, it is 8. Can you see now the combination is still the same, guys? 4, 8, or 8, 4. Hence, I said it does not matter whether this one is on this one side or that side. Okay, yes, I'm moving not so fast. I almost forgot 1.3, guys. You were gonna cry. Let me delete this page, clear the page. Okay, let me try to quickly erase this. Hopefully the simultaneous part was understood. It was in a different manner, but guys, it's still the same thing. It's not necessarily that difficult, or I just wanted you to understand what is a perimeter, what is an area, and all of those, how to get an area of a rectangle and all of that. Show that this blah, blah, blah is divisible by 2 for all real values of m and n. And you'll be like, what's going to happen now, guys? Remember, if something is divisible by 2, if you can get this expression and take 2 to the power of whatever, m, maybe minus, let me say plus or minus a to the power of n, whether it's negative or positive, it's fine. If you can have this, since well, this one has a factor of 2 thereof, it tells me that this whole part, it is divisible by what? By 2. So I need to make an expression. After that expression, see if I can take out 2 as a common factor. If I can take out 2 as a common factor, it means now this part is going to be divisible. It means this whole part is going to be divisible by 2 for all real values of m and n. Okay? Yes. So let's try to see that. Okay, another thing I'm taking note, I can take this as difference of 2 squares. Why, Mpo? Because here, can you see this minus? I can say I have x squared minus b squared. And how do I solve that? A minus b, a plus b. So I'm going to say, okay, let's apply the very same analogy. Let's trust Mpo. When we do that and trust Mpo, it's going to be what? It's going to be, the first bracket is going to be this one, okay? 1 plus x to the power of m plus x to the power of negative n minus, allow me to use this one, minus what? This one here, again. So minus this one is going to be 1 minus x to the power of m minus x to the power of negative n. Okay. The reason I'm using the bracket so that I distribute my signs very beautifully. Let us move it towards the side like this. And then remember, I will multiply. Okay, I'm just multiplying difference of 2 squares plus what? I still repeat this one. Plus x to the power of negative n. In this case, if here I used the minus, okay, let me use the minus with a different color. Minus, this one I'm going to use plus. What exactly am I adding? I'm adding this one. 1 minus x to the power of m minus x to the power of negative n. And then I can now distribute the okay. So it's going to be 1 minus 1. Can you see that 1 minus 1 is going to cancel off? And then I'm going to have x to the power of m. Negative by negative is going to be positive, x to the power of m. So it's going to be x to the power of m plus x to the power of m. So it's going to be 2 times x to the power of m. And then I'm going to have x to the power of negative n minus, which is plus. Can you see? So it's going to be plus 2x to the power of negative n. All right. Let me go to the other one. It's going to be 1 plus 1. This is just 2. And then I'm going to have x to the power of m plus and minus. So it's going to be minus this one. They cancel off. And then I'm moving on, x to the power of negative n minus x to the power of negative n. So it's just that. So can you see here? Can you see it gives me what? It gives me this part. Remember I said if you can have 2 to a to the power of l blah, plus a blah blah to the power of n, it's fine. Can you see now that 2 that I wanted? Here it is. Here is that 2. Can you see that? Can you see that? So it is beautiful. You can say it is 2 into x to the power of m plus. Okay, let me show you what I did. It is this 2 here again. And then I'm going to take out the 2 inside. There's a common factor inside. 2 to the power of x to the power of m plus x to the power of negative n. Since well, it is divisible by 2. Also this one. So I can divide. So I can write this like that. I can say, okay, let me focus on this expression alone, maybe. Okay, not that expression alone, basically, because this is going to be important. So if this was to be 3 here, maybe not 3, if this was just any constant, maybe 9 divided by 2, it's going to affect this 2. So I need to consider all of this part. So what am I going to say? Let me even rewrite it handkerchief. Let me just say it is 2 into 2 to the power of x to the power of like this. So this one is this expression. I'm going to say, therefore, this expression is divisible by 2 for m and n is an element of real numbers. Okay, so m and n can be any real number. This will also be divisible by 2 due to this one. So hence now they say show that this expression is divisible by 2 for all real values of m and n. Okay, so this one, since well it has a 2 here, it's gonna, even if this number was maybe 4 or maybe say 3 or what, but if it's going to be multiplied by these 2, it's going to become 6, and 6 is divisible by 2. So this is a key factor in us deciding. So this expression is divisible by 2 for all m and n is an element of real numbers. I hope that's clear, guys. Let's move on to question 2. Question 2, number 13. It says to us, given the arithmetic series like that, blah, 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 determine the general term of the series in the form of Pn plus Q. So how do I find the general term for an arithmetic series? Tn is equal to A plus n minus 1, the difference. What is A? 5 plus n, I do not know, I don't care, minus 1. The difference from here to here, it is positive 2, right? And then you can simplify your maths. 2 multiplied by n, 2n, 2 multiplied by negative 2, it is negative 2. Negative 2 plus 3, it is plus So negative 2 plus 5, it is plus 3. So this is my Tn, guys, in that format like that. Okay, yes. And then it says, actually, this is not a sequence, it is a series. I'm not sure if I said it is a series or sequence. The given series represents the number of kilometers that an athlete ran each week in preparation for an ultra marathon. The athlete ran 93 kilometers in the last week of the training program. Okay. How long in weeks was the training program? So we know that this shows now the number of weeks. Okay, rather it shows the kilometers ran in each week. So in week 1 he ran 5 kilometers. Week 2 he ran 7 kilometers. In week 3 he ran 9 kilometers. So we want to know in week whatever, what week did he run 93 kilometers? Okay, so how long in weeks was the training program? So we want to know when was the last week. Okay, so how can I do that? So I can do that by saying uh oh, okay. I was stuck for a moment. So I'm gonna just take this information. Okay, I want to know the number of weeks. Remember, this is the same as T1, T2, T3, Tn, but now we are writing it in terms of what? Of weeks, of weeks, of weeks. So it's like we are trying to find the Tn, which is week n. So I'm gonna just say, oh, okay, I'm just gonna come to this formula. What do I do to that formula and say, let me try to find 93, it is equal to 2n plus 3. And then it's gonna be 93 minus 3, it's gonna be 90, it is equal to 2n. And then n will be equal to 45. 45 what? Weeks. Because this, we are not referring to terms, these are not term number 1, but are rather what? Weeks. So it's going to be week 1, blah, 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 blah. So n here is week number 45. 45th week. Okay? They say to us 2.1.3. The athlete used the athlete used this opportunity to raise funds for her high school. Wow. The community sponsored her 10 rand for each kilometer run during the training program. Calculate the total amount that the athlete raised for her school. So we are told that for each kilometer ran, does the English does the English say ran? I think, yeah. So each kilometer that he or she runs, what's gonna happen? They're gonna grant her, or it's her, they're gonna grant her 10 rand. So I can if I were that if I had enough time, I could have said 5 multiplied by 10, because these are 5 kilometers, okay? Remember, this is 5 kilometers. So I could have said 5 kilometers multiplied by 10, and then multiply this by 10, multiply by this by 10, multiply by this. But I need to know how many are. So instead of doing that, let me find the sum. Remember, this is in kilometers. Let me find the sum of the kilometers that she ran, sorry. Let me find the total sum of kilometers that she ran, and then of the total, after getting the total kilometers that she ran, I'm going to multiply that by 10 rand. So it's going to give me the total amount that she collected. So how can I do that? How can I do that? I'm going to say, okay, let me find the sum of, remember here, and it is equal to 45. So she ran for 45 weeks. Let me calculate how many kilometers she had in that 45 weeks. So I'm going to say sum, remember the sum, it is A, you are lying, n divided by 2, 2A plus. But I can use this formula that says n divided by 2 is A plus L. Why? Because I already have the last term. Okay, remember, if you have the last term, you can use this formula. So it's going to be sum of how many weeks? 45 weeks. So it's going to be 45 divided by 2. What is A? A is the first term. It is 5 plus the last term. It is 93. Let's see how many kilometers she actually ran. So she ran these kilometers, 2205 what kilometers in total. Let me quickly confirm. 5 plus 93. Okay, I get 22,000. Okay, 2,205 kilometers. You can also use this formula, guys. That says 45 divided by 2, 2a, which is 5, plus n minus 1, 45 minus 1. The difference it is 2. Let's confirm if it gives us the same answer now. 10 plus 4488. It actually gives us the same answer, guys. So yeah, you can use that one. But now the focus is not about the how many kilometers. We want to know how calculate the total amount that the athlete reached for the school. So if these are the kilometers she ran, we need to multiply that by 10 rand. So you're gonna say amount, total amount is gonna be the kilometers ran multiplied by the amount of each kilometer. So it's gonna be multiplied by 10. If I'm correct, guys, I'm getting an amount of 22,050 rand. Hopefully I did not do any mistake, guys. If you spot any mistake, just know that okay, it might be that mistake, but the analogy or the steps are the same. Okay, the steps are the same. Moving on to 2.2, it says now we are considering the general term of a geometric sequence is given to me like that. Write down the value of the first term. The first term, they want term number 1. Term number 1 is going to be t to the power of 1 plus 2, which is 2 to the power of 3, which is 8. So term number 1 is just 8. The common ratio. What is the common ratio, guys? I know the common ratio is 2. But let me prove that. How do I know the common ratio? It is 2. Remember the equation, it is Tn a r n minus 1 for the what? For the geometric series. So I can say 2 to the power of n multiplied by 2 to the power of 2. And then so it's going to be 4 multiplied by 2 to the power of n. So this is in the format of a r n minus 1. It's just unfortunate to not have the minus 1. But can you see this one? It's r. Yes, beautiful. So calculate T20 and then write your answer as a power of 4. Oh, okay. Okay. Now T20 is supposed to be easy. It's going to be 2 to the power of n. Okay. 20 plus 2, which is 2 to the power of 22. Do I want to use my calculator? No. It's going to be a long number, but they want me to write my answer as a power of 4. Okay. So you can punch your calculator. I don't, because it will never give you in a power of 4. So how can I raise this to be a power of 4? Guys, I can rewrite this as 2 to the power of, I can divide this 22 by 2 so that it becomes 2. And then, do you agree that 2 multiplied by 11 is the same as 22? So if I do that and then decide to say 2 to the power of 2, group it together and put 11, that's still the same because I'm still having 2 multiplied by 11 is 22. And then, so it's going to be now equal to 4 to the power of 11. Okay? Sharp. I think we are fine, guys. 4 to the power of 11. 4 to the power of 11. And then they say calculate the sum to infinite. How do I know it is sum to infinite? I see the sign. I start from 1 to what? To infinite. Of what? Of 1 divided by Tn. Now I have Tn. But guys, it's easy. What you can do, you can find S for infinity for Tn, and then the final answer, say 1 divided by the answer. But what you can also do is, okay, whatever that is going to be on Tn, remember for sum to infinity, I need what? A into 1 minus r. So if for Tn, A was, remember A is the first term, is if A was, this is for Tn. If for Tn, A was 8, and R was 2. Do you agree that for 1 divided by Tn, everything is just going to flip? A is going to be 1 divided by 8, and R is going to be just half. So it's easy, guys. A is going to be 1 divided by 8, all divided by 1 minus 1 divided by 2. So let's see how much you get. 0.125 divided by 0.5. You get 1 divided by 4. Okay. What you could also do is say, okay, let me find the sum to infinity of Tn. When you find the sum to infinity of Tn, it's going to be A 1 minus 2, which gives you what? What's this? No, I don't think it's going to be the same. It's going to be the same, I doubt. Okay, let's check. 1 minus R, it's 2, and then I'm going to get just negative 8. When I flip it, it's going to be negative 1 over 8. So no. No, it's not. So yeah, guys, it's this answer. 1 over 4. Let me just quickly confirm my calculations. 1 divided by 8. Okay. 1 minus half. Yeah, just 1 over 4. Fine, guys. The interesting one says now to us, calculate the first 21 terms of the series. I'm lying. Consider the first 21 terms of the sequence, this one. And then what about them? Calculate the sum of the terms in this sequence that are not powers of 4. How? That are not powers of 4. Okay. How can we see if there's a powers of 4? Remember, they said we should write this as power of 4. And initially it was 2 to the power of 22. So I'm thinking, okay, if this value was 2 to the power of 23, we couldn't do what? We wouldn't have been able to change this to the power of 4 because I cannot divide this by 2. Okay, I can go somewhere. Let me consider the first, I don't know how many terms, but I need first to, okay, let's say this is T1, T2, T3, T4, T5. I want you to see something, T6, and then I am going to continue. I'm going to continue up to T21. I want you to take note of something. Term number 1 is going to be what? T1 is going to be 2 to the power of 1 plus 2. You agree? Which is 2 to the power of 3. Term number 2 is going to be 2 to the power of 2 plus 2. It is 2 to the power of 4. This one can be what? 2 to the power of 3 plus 2. It is 5. 2 to the power of 6. 2 to the power of 7. 2 to the power of 8. And then T21 is going to be 2 to the power of 21 plus 2, which is 23. Okay, I can consider T20 here. It's fine if I do that. It's going to be 2 to the power of 22. So they say calculate the sum in this sequence of the terms that are not of powers of 4. Let's see which one cannot be expressed as power of 4. This one I can express it to the power of 4 because it can be 2 multiplied by 2. So that it can be 4 to the power of 2. This one can be 2 to the power of 2 multiplied by 3, which can be expressed as 4 to the power of 3. This one can be 2 to the power of 2 multiplied by 4, which is 4 to the power of 4, all the way to 4 to the power of 11. Can you see now? T1, or the odd numbers cannot be expressed as what? As power of 4. So I want to find the sum of those terms. Okay, I need to find the sum of those terms. Which terms am I talking about? So it means if I were to consider their pattern, it's going to be just 2 to, the first term is going to be 2 to the power of 3. The second one is going to be 2 to the power of 5, 2 to the power of 7, all the way to 2 to the power of 23. So this is my sequence that is not powers of 4. Okay, not powers of 4. And then I can try to find their sum. How can I find their sum? It's gonna be, what's the difference here? Okay, I don't think it is the arithmetic. I think it is geometric. How do I know that? When I say this divided by that, it's going to be 2 to the power of 5 divided by 2 to the power of 3, which is 2 to the power of 2, which is equal to 4. So, okay, from here to here, the difference, okay, the ratio is 4. From here to here, is it the same? 2 to the power of 7, 2 to the power of 5, 2 to the power of 7 minus 5, it is 2, it is 4. It's the same. So the value of R, it is 4, and the value of A, it is 2 to the power of 3, which is 8. Okay? So how many terms do I have? Don't hesitate or try to do something. How many terms do I have in total? 21 terms. How many terms are? Can you see? 1, 3, 5 are the ones that are what? That are that are not cannot be expressed to the power of 4. So let me consider this one. How many ones can be expressed to the power of 4? It is from T2 to T20. So from 2 to 20, how many even terms do I have? Even terms do I have from 2 to 20? It's going to be 10, guys, because it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means if even terms, there are 10 even terms, and the total it is 21. How many do we have of the odd terms? Which are these ones, the T3 and T what one? How many do we have of this one? It's going to be 11. Do you agree? 21 minus 10, it is 11. So we have n, it is equal to what? 11. So let's just find its sum, guys. I think now everything should be fairly easy. Sum is going to be a r minus n minus 1, r to the power of n minus 1, sorry. And then r minus 1. Sum of how many terms? 11 terms. First term, it is 8. R, it is 2 to the power of 11 minus 1, lying 4 divided by 4 minus 1. Let's check how much do you get, guys. 8, 4 to the power of 11 minus 1 divided by 3. You get, you get 1 million, 11 million, 11 billion. I don't know how to call this number, guys, but I want to believe you can see it on your respective calculators. So this is what you get. Okay. Yes. I think I explained it thoroughly, guys. I think you understand how I explained this. Why can I not express this to the power of 4? Because, guys, when I say 3 divided by 2, it is a 1,5, so it's not a whole number, so I cannot. Let's move on to the other questions, guys. Question 2 was not that bad. It was tricky. So reconsider the quadratic equation like that. Tn, it is equal to that and what and what and what and what. So I have 14, 9, 6, 5, blah, blah, blah. Show that the general equation is given by that. Okay, guys, this is grade 11 stuff. What's interesting or what's special about a quadratic? It has the second constant difference. So it means the first one, it is what? It is an arithmetic. So 9 minus, guys, term 2 minus term 1. 9 minus 14, negative 5. 6 minus this one. 5 minus this one. So remember, guys, this forms me the what? The arithmetic sequence. This one forms me the arithmetic sequence. This one, it is the quadratic. Again, and this one will be the second difference. Guys, negative 3 minus 5. Negative 3 minus negative 5. It's going to be 2. Negative 3 minus negative 5. Guys, is 2. So this is the second constant difference. So, ouch. Then I need what? I need to say, okay, therefore, I know that, therefore, 2a is going to be equal to what? 2. Therefore, it means a is going to be equal to 1. And then I know 3a plus b is going to be equal to 5. Negative 5. And then when I substitute that, I play with my mathematics. It's going to be 3 into 1 plus b is equal to negative 5. And then b is going to be negative 5 minus it is negative 8. So I have b to be equal to negative 8. And then this is a plus b plus c is equal to 14. What is a? 1 minus 8 plus c is equal to 14. Then this is negative 7. When it goes to the other side, it's going to be 21. So c it is equal to 21. Is it correct now? N it is 1. B it is negative 8. C it is 21. Beautiful. Beautiful, guys. Beautiful, guys. Okay, and then two consecutive terms of a quadratic sequence have a difference of 33. So two consecutive terms of the quadratic sequence has a difference of 33. Calculate the value of the larger term. So guys, if I'm having the first two terms, so the difference between them will give me the difference again, which is negative 5. But the ones that they are talking about there, I do not know where they are. But this term here and this term here, let me say, this term here plus this term here, their difference should give me what? 33. 33. So guys, what I want you to take note of is that this is term number 1, number 2, number 3, number 4, and say, so when I say T2 minus T1, I get T1 of the arithmetic. T3 minus T2, I get T2. So T2 minus T1, I get the smaller between the two. T3 minus T2, I get the smaller between the two. So it means here it will be T3. So it means here if it was T50 and T51, so here will be term number 50. So if I wanted to find the biggest term, it will be term number 51. Okay, what do I mean by that? I need to find n. Okay, for this one, it is on position number man. I need to find the position of 33 on its pattern. Remember, I said this one forms a what? This one forms a linear pattern or an arithmetic pattern. So if it forms a linear pattern, let's find its equation. Its equation is going to be Tn. It's going to be 2n minus 2 negative 5. Okay, let's do it manual, guys. And then what is the value of a? We are considering this pattern, guys, in blue. First term, it is negative 5 plus n minus 1. The difference, it is 2. So it's going to be just Tn is equal to 2n. Negative 1 multiplied by 2, it is negative 2 minus 5 minus 7. Okay, so yeah. So this is the term. But I want to find, or this one, it is in position number man. Okay, I want to find this one, it is in position number man. So I say, okay, let me check if 33, it is in which position, basically. 2n minus 7. And then when I play with my mathematics is going to be 40. 40, it is equal to 2n. And then n is going to be equal to 20. So if this one, it is on term number 20 here, which two terms form term number 20? Do you agree it is term number 20 and term number 21? So can you see T1 minus T2 minus T1, it gives me term number 1. So it means here it's going to be T21 minus T20. It's going to be T20. But now the question is, two consecutive terms again. We know those two consecutive terms, it is term number 20, term number 21. And then it says calculate the value of the larger term. The larger term, it is which one? Term number 21. So I'm going to go to term number 21 of the what? Can you see? Of the quadratic equation and substitute 21 to it, and I'll find that value. Okay? I'll say T21 on the quadratic is going to be 21 squared minus 8 into 21 plus 21. So it's going to be 21 squared minus 8 into 21 plus 21, guys. So the largest term there is 294. So if they said between, okay, this question they can ask you like this. Between which two consecutive terms in the quadratic, okay, which two consecutive terms in the quadratic pattern has the difference of 33? Okay, if they wanted those two consecutive terms, we will have found what? T20 first. T20 is going to be 20 squared minus 8 into 20 plus 21, which is equal to how much? 261. So it was going to be therefore between 261 and 294. Okay? Or between which two consecutive terms? It is this one or this one, or between T20 and T21. Because when I say 296 minus 296 minus 2, guys, 294. Yes, I get the difference of 33. So yeah, that's basically that, guys, for that question. It's the grade 11 type of question, by the way. But it does not mean it is not assessed in grade 12. It is there. You can see it is there. Do not want to prove it when you are the one writing the paper, guys. You can see here. What's the next question wanting from me? Okay, I'm saying it's fine. Okay, it's fine. Let me erase this so that I give this question an attention, and here it's very beautiful. It says the term, okay, the value of m is added to each term in the quadratic sequence. Determine the value of m for which will only, okay, let me repeat that. Determine the values of m for which only the terms between T1 and T7 of the quadratic sequence will have negative values. Okay, before that, let's write the first 7 terms so that we make sense. If this one, 1, 2, 3, 4, okay. So it's going to be, first term, it is 14, 9, 6, 5. So how can I find the next 3 terms? Okay, you can do that, but I see this, it is a parabola, guys. That is facing downwards. It is a parabola like this. Parabola like that. Okay, so it means it starts from 14 and the value decreases to 6. When it reaches 6, okay, it decreases any further. Let me see, 4, 9, 6, and 5. So it decreases. So let's look at the next term. It will be what? Which is term number 1, 2, 3, 4. 2, 4. Let's look at term number 5. I can go to my quadratic equation and find term number 5. It's going to be 5 squared minus 40 plus 21. This is 6. So it goes back to what? To 6. And then if it goes back to 6, since well, it is a parabola like this. So here it stops at 5. This is 5. And then if this was 6, this is going to be 6. If this was 9, this is going to be 9. If this was 14, this is going to be 14. You can use your calculator to prove that, guys. 9, 14. How many terms? 1, 2, 3, 4, 5, 6, 7. Cool. These are the 7 terms. Okay? But what? Term number 1, term number 2, term number 3, term number 4, term number 5, term number 6, term number 7. Let's hear what the question is saying to us. The value of m is added to each sequence, okay? So it means now our first term is now going to be 14 plus m, second one, 19 plus m, 6 plus m, 5 plus m, 6 plus m, 9 plus m, 14 plus m. And then they say what? I'm going through this. Determine the values of m for which only the terms between T1 and T7 of the quadratic sequence will have a negative value. So what is the value of m for which the terms between term number 1 and term number 7? So between, if this is term number 1 to term number 7, the terms between are these ones. So which value of m which values of m? Oh, okay. Determine the values of m for which only the terms between T1 and T7 of the quadratic will have a negative value. So which value of m can make all these terms negative? Okay, let's start here. 9 plus m, we need that to be negative. For this term to be negative, the value should be less than 0. Okay, if it is less than 0, it means 9 should be less than negative 9. Okay, let's check. Let's check what happens when 9 is less than negative 9. Negative 9 again. So let's take a value that is less than 9. A value that is less than 9, let's take negative 10. What will happen if I take negative 10? It's going to be 9 minus 10. It's going to be what m should be. Let's take m, it is equal to negative 10. It's going to be what? 9 minus, it's going to be negative. This one, 6 plus 5, 6 minus 10 is going to be negative 4. So 5 minus is going to be negative 5, 6 plus, okay, negative 4, negative 1. So, okay. So it means now the value of m should be less than 9. Why? Because I took the largest one. Okay. The question is, well, how about 6, this one, 6 plus m is less than 0. Okay, it will be fine. M should be less than negative 6. But if we take m is equal to negative 7, can you see if I were to say 9 minus 7, it will give me a positive number. So it won't be good. So I need the value of m to be greater than the one that is the biggest. Okay, so this one. But now, okay, this m will make these ones, if m is less than 9, it will make all these terms here in the middle to become negative. But now let's come to the first term. It means the first term does not need to be negative. It means we need this one to be 0 or positive. So if this, we can continue with a value less than negative 9. Let's say we take m as negative 13. If it becomes negative 13, it's going to be 14 minus 13. Okay? So it's going to be 1. It's still positive. Remember, this value and that value is still the same thing, guys. So I'm going to focus on one side. It's 1. Okay? If I take m as negative 14, it's going to be what? This is going to be, if m is equal to 14, it's going to be 14 minus 14. It's going to be 0. Okay? It's not negative. It's not positive. It's fine. But if m was to become negative 15, do you agree this is going to be negative 1? So, we just stop there. We do not want m to become negative 15. So it means m can be negative 14, but not more than this. So it means whatever value that I choose for m for this one, the value that I choose for this one, it should be greater or equal to 0. This value here should be greater or equal to 0, guys. What do I mean by greater or equal to 0? They said here specifically, determine the values of m for which only the terms between T1 and T7 of the quadratic will be negative. So only this one, we want them to be negative. But if we cannot just say m should be less than negative 9, because m is less than negative 9 can be m, it is equal to negative 30. It is also less than 9. But if I were to substitute it here, it's gonna result in a negative answer, and I don't want the first term and the seventh term to be negative. Okay, only the ones that I want to be negative are the ones in the middle. Okay, so these ones, the first term and the seventh term, I need them to be zero. They can either be zero because they did not say they cannot be zero. So they can either be zero or positive, but not negative. Hence, I need to say this term here needs to be greater than zero, which is positive, or exactly zero. So this will result to m being what? Greater or equal to what? To 14. But I need to put that in a number line. Oh, okay, it means my values should be play between this one. It means now on my number line, I need, okay, it can either be between negative and negative I more. M should be less than negative 9, but M should be greater than or equal to 14. Guys, why am I saying great? Let me quickly confirm this. Let me check this. And we said the value should not be more than, less than 14. Or it's negative 14, basically. So, okay, negative 14, negative 9. What are we saying? We are saying this value, M should be greater than negative 14. Greater is moving to that side. Greater or equal. But M should be less than, so it's going to that side. But M should be less than 9. But it's not included. Can you see? To that side. So can you see that, guys? So it should be between these two values. So the final answer will thereof be M should be between negative 14 as well as negative 9. If M is between these values, then it's gonna meet, it's gonna satisfy the condition that these ones are gonna be negative and this one are gonna be positive or equal to 0. I hope that's clear. You can also write it like this. X should be between negative 14 and negative 9. Do not include that. Okay. Yeah, that's that, guys, for question 3. Move on to question 4. What does question 4 say to me? The graph of f of x, it is equal to this one. We can see it is not quadratic, sorry, guys, a hyperbola. M is the point where the asymptote of f intersect. So this one, it is the point where the asymptotes intersect. And I can easily find that point. How? Because I know this line, I have the equation of the asymptote, which is x it is equal to 3 and y it is equal to 4. So if x is equal to 3 here and y it is equal to 4 here, they intersect here. So the coordinate of m will be something like 3 and 4. I'm just collecting what I have. And then C and D are x and y intercept respectively, okay? C and D are just x and y intercept. A is a point on F that is closest to M. Okay, this point is closest to M, almost to M, but not to M. Closest, sharp. Calculate the coordinates of M. Guys, the coordinates of M, write down the coordinates of M. Coordinates of M are 3 and 4. How did I know? The equation is x is equal to 3 and y it is equal to 4. So in terms of coordinates, it is 3 and what? And 4. Calculate the coordinate of D. What is D, guys? D is the what? Y-intercept. So for y-intercept, I let x equal to 0. So I'm going to say 4, 0 minus 3 plus 4. It's going to be 4 divided by negative 3 plus 4, which is 80 divided by 3. So the coordinate of D, guys, it is when x is 0, y it is 80 divided by 3. And then sharp. Easy marks so far. If y is equal to x plus t is the equation of the line, of symmetry of f, calculate the value of t. Okay, already I was given y is equal to x plus t. So the x plus t automatically tells me that my gradient, it is dual, it is positive. So I actually, it's just you finding find the equation of a line of symmetry that has a positive gradient and then just compare. But what you can do, you can say, okay, that line is going to pass here. It's going to pass here. Let me do this, guys. It's going to pass here with a positive gradient. It's going to pass here. It's going to pass there like that. I'll use a different color. I don't want to read. Okay. So it's that, guys. So this one will be x plus t. So we need to find that t. It passes through which point? This one, 3 and 4. So you can say, okay, I'm already having this one. Let me just substitute. Okay, remember this as an equation of y is equal to x plus t. Let me substitute the coordinate of y is equal to 4, x. Okay, x, it is what? 3 plus t, and then t will just be what? 1. Okay, t is equal to 1. Or what you can do, you can say, I know I can find it using this part. Okay, so it's going to be y is equal to x minus 3, okay, with a positive gradient, plus 4. And then I'll have y is equal to x plus 1. So what's the difference between this equation x plus 1 and this equation? It tells me that, oh, therefore, t it is equal to 1. Are we fine, guys? I think we are fine. Then determine the values of x for which f of x is less or equal to 0. Where is it less or equal to 0? Less or equal to 0, it means it is above. So below the x-axis. This is the x-axis, guys. So where is it below? It is below from C to there. So let's find first the coordinate of what? Of C. We need first to find the coordinate of C because it is between C and the what? And the asymptote. So what is C? What is C, guys? C, it is the C, it is the what? The C, it is my y-intercept, basically. Not y-intercept, x-intercept, basically, guys. So how can I find my that one, x-intercept? It's easy. You know, for x-intercept, you let what? Y equal to 0, and then you become a what? A mathematician, you solve. Let's do that. 0, it is equal to, what is my equation? 4. Guys, is it negative 4? Guys, I think it's negative 4 here. Why? Because, no, it's positive 4. No, it's positive 4. Because if A is greater than 0, it is drawn on quadrant number 1 and quadrant number 3, and that's the case, okay? If A is greater than 0, it's drawn on quadrant number 1 and 3, and then if A is less than 0, it's drawn on quadrant number 2 and 4. Oh, okay, yeah, guys. So it's that way. I'm not seeing it very beautifully for you. It's gonna be a struggle. Okay, so where am I? Oh, I was still solving here. X minus 3 plus 4. Okay, I want that value there off. And then I'm going to take the 4 to the other side. Negative 4 is equal to 4. X minus 3. Multiply this to the other side. Negative 4 into x minus 3. It is equal to 4. Divide by negative 4. Divide by negative 4. X minus 3. It is equal to negative 1. And then take this 1 to the other side. It's going to be x. It is equal to what? 2. So the coordinate here, it is 2. Okay, the coordinate here, it is 2 and 0. But I'm just interested in x. It is 2. So if x is 2, guys, if x is 2, then I can say, therefore, it is between my solution, f of x is less or equal to 0 when x, it is between what? 2 and what? What is the asymptote? The equation of the asymptote here, it is x is equal to 3. Remember, I wrote it here. This one, it is x, it is equal to 3. The vertical asymptote, the horizontal asymptote, it is y, it is equal to 4. Okay, so between 2 and what? And 3. But 3, I cannot include it. Why? Because it is a what? It is an asymptote. Because and the asymptote, the graph does not touch, despite the examiner saying less or equal to. Okay, so someone might say this one, or x, it is between included 2 but excluded 3. Still fine. Calculate the coordinates of A. What are the coordinates of A? What is A? What did they tell us about A? They said to us, A, it is the closest what? It is the closest. Here is A, guys. They said to us, A is the point on F that is closest to M. Okay, that is closest to M. So what you can do it in 2 steps. So I'm gonna do step number 1. Step number 1, you can say the coordinate of A, since well it is closest to M. Okay, so it will have a positive what? Positive y values and positive x values. Can you see that? So it's gonna be what is this? Coordinate of 3. Coordinate of M, which is 3 plus square root of P. Okay, those are the x. Sorry. Square root of A plus square root of P. On the y, it's going to be square root of x, square root of A, guys, square root of A. Plus, remember P represents the x, and then what represents the thing, it is Q. This is not square root, but just Q. So you learn this in grade 10 and 11. If you did not, it's fine. Every time when they talk about the closest point on M, you either use this. How do I know that the root here is going to be negative or positive? You check, okay, it is on quadrant number 1. Again, on quadrant number 1, the value of y here, it is what? It is positive. Also, the value of x, it is positive. But let's say we had a point here. They were talking about this point. Okay, this point will also have a positive and positive. Let's say we had a graph like this. So can you see, if I were to apply that here, the point closest to M, I will have done what? I will have said the y are going to be negative and the x are going to be negative. So I was going to use this one, negative square root of A, since well it is going to be the negative, plus P again, and then negative square root of A on the y, because y is also negative, plus Q. But in this case, that's not the case. So it's going to be this one. And then when I substitute, it's going to be what? It's going to be, I'm going to substitute here. A is going to be square root of 4 plus what is P? What is P, guys? Remember, P is going to be, if this is negative 3, P is equal to 3. Remember, okay, let me come back here. Let me confirm something, guys. Oh, I'm gonna just okay. P and Q are my coordinates here. Okay, because they are closest to M. Okay, so do not confuse yourself. P and Q are those coordinates. What is P? P is 3. And then here I have square root of 4 plus what is Q? Q it is 4. So here I'm having 4, square root of 4 plus 3, which is 2 plus, it is 5. And then square root of 4, which is 2 plus 4, it is 6. So A, it is 5, and 6. Another way, if you this one you did not learn it in grade 10 and 11, what you can do is, I know this graph y is equal to x plus 1. Okay, it is at this point they share a common point. So if they share a common point, it means the equations need to be equated. So I need to equate what? 4. I don't have enough space. I need to equate 4 x minus 3 plus 4 with what? With x plus 1. So when I take 4 into x minus 3 and equate 4 to the other side, is going to be x minus 3. And then 4, when I multiply this to the other side, is going to be x minus 3 squared, because I'm multiplying x minus 3 to the other side. So when I square root, it's going to be plus or minus 2 is equal to x minus 3. So x minus 3 can equal to 2, or x minus 3 can equal to negative 2. Then x is equal to 5, or x it is equal to 1. But the question is, which one is the correct one? Can you say they intersect here as well as at A? But here it can say, okay, this one can be 1, but this one cannot be 1. This one is 5. So I need to take 5. Again, I need to take 5 and substitute it to any equation. I'm going to substitute it to this equation, okay, of y. So y is going to be equal to, this is the coordinate of A. I can substitute y into this equation, this one or this one. So can you see, when I substitute to the equation of my symmetry, it's going to be, where is it? X plus 1, which is going to be just 5 plus 1. 5 plus 1, which is 6. So the coordinate of A is going to be, when x it is 5, y it is equal to 6. But can you see that we also got the same answer by using the thing is there of? Beautiful. Okay, guys. Okay. So let's consider another question. It says a single transformation is applied, so it is one transformation, is applied to F to obtain a new graph defined as h of x is equal to that. Okay. And they tell you A is the image of A under this transformation. Calculate the length of AA. Okay. Let us see if my f of x was 4x minus 3 plus 4. How did it transform to h of x? It is equal to negative 4x plus 3 plus 4. Okay, we have 3 types of transformation that are common. A reflection across the y-axis, reflection across the x-axis, reflection across the line y is equal to x. Okay, that one we cannot consider it because it's going to be just a different thing. Let's look at the first one, reflection across the y. Let's reflect this across let's reflect f of x across the y. We want to see if it's the same as this one now. When I reflect across the y, reflect across the y-axis. When I reflect across the y-axis, I'm going to change what? The x. Okay? So when I'm reflecting across the y-axis, like, let me make an example. If this point here, it is A and B. If I reflect it across the y, do you agree that x is going to change to negative A, but B is going to remain the same? So let me say this is x and y. So can you see that x is going to change, but y is going to remain the same? So if I'm reflecting across the y, I'm changing the x. So it means now I'm going to reflect across the y, but I'm going to change the x to negative. So it's going to be 4 into negative x plus minus 3 plus 4. Okay? I just transformed across the y. Okay? Now, okay, I do not want this one to be negative, to have negative x. How can I change that? I can change that by saying 4 divided by negative into, I'm taking out the negative, x plus 3. I'm taking out negative as common fact, plus 4. And then I can just take this negative up there so that it becomes negative 4x plus 3 plus 4. Can you see now this graph here? It is the same as this graph of h of x. Yes. So it means now the reflection that happened there, it was the reflection about the line, about the y-axis, because x changed. Let's see what would have happened if they reflected across the y, the x, I mean. When I have a point again, x and y, when I reflect it across the x, what's going to change? X is going to remain the same, y is going to be negative. So let's reflect this across the x and see if we are being honest now. Reflect across the x. So this one will change to negative. F of x, it is equal to 4 into x minus 3 plus 4. But I do not want to have my f of x as negative, so I'm going to divide everything by negative 1, negative 1. When I just apply chain sign rule everywhere, when I divide by negative, I'm going to apply chain sign rule everywhere. It's going to turn out to be f of equal to, this one is going to be negative 4 into, remember when I just multiply this by negative, it's going to be that fell. It's minus 3 and then minus 4. So can you see that this is not at all the same as this? So it means the correct one, it is reflection across the y-axis. But now that's not the question, Hori. How did we reflect it? It says now, A is the image of A under the transformation. Calculate AA. So we needed to see how is it reflected. So it means A with the coordinates of 5 and 6, we just found again there, 5 and 6. How can we will get A prime by reflecting this across the x-axis. Remember I said when you reflect across the x-axis, what changes? Across the x remains the same, so it's going to be 5. And then y is going to change to negative 6. So A has these coordinates, these ones. Okay? So if now A prime has this coordinate, how can I find the distance, the length between the two? I can just apply now distance formula. So it's going to be x1 minus x2 minus x1 squared plus x2 blah, 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 blah. So I'm going to say x2, it is what? 5 minus 5 squared plus negative 6 minus 6 squared under the square root. This will give me square root of 36, which is equal to 6 units, guys. No, guys, I'm lying, guys. 12. You'll get square root of 144, which is 12. Remember 5 minus 5, it is 0 squared plus negative 6 plus this, it is negative 12, negative 12 squared. So this will just be 0. Negative 12 squared, it is 144. So square root of 144, guys, it is 12. So the distance, it is 12 units. You need to know the reflection of how did they reflect the graph of f first, so that you will see how you can find the value of what? Of A prime. Hopefully it is clear, guys. Let's move on to the next one. Question 5, parabola. It says, parabola given in f of x is equal to blah, blah. This is in the standard of a parabola, okay? Parabolic standard. Is drawn. C of this coordinate is the turning point and B is the point or any point, okay, on F. So, okay. Show that the graph of f of x is equal to negative 2x squared minus 5. It's easy. Why am I saying it's easy? Just say, okay, already you know these turning points, and this is in a turning point formula. So it means now you're going to say y is equal to a into x. If this is negative here, when it goes there, it's going to be positive. Remember, plus 1 squared plus 4. But I'm not done. I need any point. Any point, it is negative 3, negative 4. Why? Negative 4. So that I solve for a. I get negative 3 plus 1 squared plus 4. This is negative. When I take this to the other side, is going to be negative 4 minus 4, which is negative 8, is equal to negative 3 plus 1, it is negative 2. Negative 2 squared, it is 4a. And then a will become negative 2. Is it correct that the value of a is negative? Yes. Why? Because the face is facing downwards. It is said. Okay. Now that we know this one, I can say therefore f of x, it is equal to negative 2 into what? X plus 1 plus what? Plus 4. But now they want me to simplify it in the standard. So I'm going to say, okay, f of x will just be negative 2 into simplify this or expand that, 2x plus 1 plus 4. And then f of x will just be negative 2x squared. Negative 2 multiplied by positive 2x is going to be negative 4x. Negative 2 plus 1 is going to be negative 2 plus 4, which will just end up being what? Plus 4. Is it correct now? Indeed. Indeed. Can you see? Negative 2x squared minus 4x plus 2. So it's that, guys. You just needed to remember that the coordinates of the turning point can be substituted into this equation and then get any other point to find the value of a and then simplify any beautifully further. Beautiful, guys. Beautiful questions. It's the best fan. Okay. 5.2. Determine the values of k for which this one will have no real roots. So f of x plus k will have no real roots. Remember how are roots? These are real roots. These will be equal roots. But discriminant one is less than 0. It is now no roots. Unreal roots. Now we want what? These to have unreal roots. So we need our discriminant to be less than 0. Let's find h of x, basically. Let's find h of x. H of x, it's just f of x plus k. So it will be a negative x squared minus 4x plus 2 plus k. But I want my discriminant to be less than what? Less than 0. Remember this. Let me do this. This is ax squared bx c. So my discriminant, remember my discriminant, which is equal to b squared minus 4ac. I need it to be less than 0 for them to have unreal roots. Okay? Unreal roots. So now what is b? b it is what? Negative 4. Agreed. Minus 4. What is a? A it is negative 2. Can you see? What is c? C it is every constant. Less than 0. Okay? I'm having 16 minus. This is going to be negative 4 multiplied by negative 2. It's going to be positive 8 multiplied by this one is positive 16. And then negative 4 multiplied by negative 2, it is positive 8 multiplied by k, it is positive 8k. Less than 0. I can take 8k less than, I can take this 32 here to the other side, it's going to be negative 32. So I need k to be less than 32, 16, 4. Okay. Another way I can do this, I need k to be less than negative 4. Okay. I need k to be less than negative 4. Another way I can do this, guys, I can say, let me consider this graph. How can my graph have unreal roots? Let me do this. How can my graph have unreal roots? Remember, roots means my x-intercept. How can I make this graph to have no roots? Do you agree that if I were to move this graph, let me remove this. If I move this graph downwards like that, upwards like this, can you see I'm still having roots where? I'm still having roots where? Here and here. I'm still having what? My roots. My roots, guys, my roots. But now I don't want to have roots at all. Okay? For me to have no real roots, I need not to have this root. What's happening? I need this. When I move it up, I still have root. But let's consider when I move it down. When I consider it, when I move it down, 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 can you see it is 4 there? When I move it down less than 4, blah, 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 blah. When I move it here, I have moved it exactly, sorry, I have moved it exactly -4 units downwards. Okay, so I have moved it 4 units downwards. Okay, so far t it is equal to -4. Okay, so far. But if t, let me do this. If t it is equal to -4, meaning it has moved down -4 units, it has one root. It has one root. How do I see that? I see that because here I'm still having a root here. It still touches my graph. So I need to move it further than that. When I move it further than 4, when I move it further than -4 downwards, it means it will not have any root. Can you see? It will have no roots. Can you see? So this is what I want. This is what I want. This is what I want. So it means now t needs to be less than -4. Okay, what do I mean? If t is less than -4, an example, if t were to be -5, can you see from here to here, it is exactly -4. So from here to here, it can be maybe -5. Can you see? So if just t is, because when t is exactly equal to -4, it gives me one root. So I need it to be further than -4. It should be less than -4, guys. So still, can you see that this is the answer that we got there? That k should be, or in this case we are talking about k, but it should be what? It should be less than 4. So let me clear those thingies there, guys. Okay, so yeah, that's basically that, guys. But you can do it this way, it's still fine. Okay, yes, it's good that you know all the methods. Let's move on to the last one. I think it's the last one under this question. Okay, it says the graph of y is equal to the inverse of the derivative of, not the inverse, the derivative of g. The graph of y is equal to g prime x, where g prime is the derivative of g, okay, is obtained when f is reflected over the line y is equal to 4. Okay. Draw a sketch of g if g of 0 is equal to less than 0. It means now, remember g of 0, it is the y-intercept. How do I know? It is y when x is equal to 0. So the y-intercept should be negative, less than 0, okay? Clearly indicate any stationary point on your graph, if we have. Okay, let's try to reflect that graph. Here's my graph. Let's try to reflect it across this line and see exactly what am I going to get. Let's try to reflect it across this line, guys. And see exactly what do I get. When I reflect it across this line, do you agree it's just gonna flip like a mirror? It's just gonna flip and look something like, this is what? G prime of x. They have told me that the graph that I get after reflecting uh, the graph of f about this line is given by this one. And they asked me to draw a sketch of G. Okay, guys, if G prime is a parabola, it means G is a what? It means G, it is a cubic function. Remember, guys, when G is a cubic function, when I derive it, I get a what? A parabola. Okay, of what shape? Can you see here? my parabola is set like this. So it means my cubic function had the last shape set. They share the common last shape. Can you see that? Okay. But now I need, okay, I can see it is something like this. Okay. Something like that. But I need to know the stationary points. How do I get the stationary points? Remember the x-intercept of my, okay, let me explain this again. If I'm having my cubic function like this, the coordinates of the turning point, the x coordinate of the turning point, the x coordinate of the turning point are gonna be my what? My, and then, okay, when I derive this one, this is f, right? When I derive it to get f prime, the x coordinate of my turning point will become my x-intercept for my new graph. And then my point of inflection, the x coordinate of my point of inflection is going to be my what? My turning point of my derivative graph. And I know my graph is supposed to look like this. I look at the last shape. So it means it's supposed to be somewhere here. And do something like that here, something like that. Okay? Yes. You're supposed to get something like that. And then, but in this case, you realize that, okay, it means it means when I want to get my x coordinate of my stationary points, remember these are the stationary points, I need to look at my x coordinate of my what? Of my parabola. But can you see now, in actual fact, my parabola does not have any x-intercept here because the line of x, it is here. So it does not have any x-intercept, you agree? So if it does not have any x-intercept, it will look like this one. It means my cubic function does not have stationary points. If this one does not have x-intercept, it means my cubic function does not have what? Stationary points. It means my cubic function is going to look like this. It's going to be this graph. That does not have what? Turning points. But the point of inflection here, we will have. Where will we have that point of inflection? We will have the point of inflection by looking at what? Remember, how did we translate point of inflection? We say the point of inflection is going to be equal to the turning point here. Oh, so it means the turning point here is going to be my what? My point of inflection. So my point of, just the x coordinate, guys, just the x coordinate. So the x coordinate is going to be what? -1. -1 there. And then I'm told that where it cuts my graph at the y-intercept should be less than 0. The y-intercept should be less than 0. So if I were to try to draw that sketch there, the graph of G, okay, I would say, remember my graph should look like something like this, okay? Why? Because the graph was like this with a set face. So it means the last part should be concave up also, okay? So it's the set face, that one, like that. So it means my graph should look between these graphs. It's either gonna, they told me it should cut at the negative. Okay, y-intercept is negative. So I can cut it here and say my graph cuts here and looks something like this. Like that. And say the point of inflection here, I know the point of inflection here. I can say I know the point of inflection here. It's aha. So the point of inflection here, it is x is equal to -1, basically. So x is equal to -1. It's supposed to be somewhere. This cannot be -1. Let me see if I were to draw this graph like okay, but the y is positive here. So it means, okay, let's never mind the stationary point because they did not say anything about the stationary point. So if I were to draw it, I draw it like this, X and Y, and say this is the graph of G. And I'll indicate that clearly, they say clearly indicate any stationary points on your graph. And I do not see any stationary points. Okay? Unless I'll be forced now to flip this coordinate and say it is now here. I'm not sure to still call it X or negative X. But now, if it is reflected like that, it means this point here, whatever this point is here, it needs to be moved plus 8 units to there. So if I were to do that, maybe, okay, let's see what are the x-intercept for this one. What are the x-intercept for that one? Okay, the x-intercept, I'll do that quickly. It's going to be x squared plus 2x minus 1. Guys, there's no way. X squared plus 2x minus 1. It seems like this one does not have vectors, x-intercept. So let's see. Let me use quadratic formula. Negative b plus or minus b squared, b squared minus 4a c divided by 2. Yo, guys, I get x is equal to 0.41 and x is equal to negative, yo, negative 2.41. So here it is negative 2.41, here it is 0.41. Okay, it makes sense. So if I were to want to write the coordinates thereof, I just, from here to here, it is 4 units. From there to there, it is further 4 units. So I'm going to say the coordinates, Tamona. Okay, the y, actually, the x is the same. I think the x is going to be the same. But also the y still needs to be the same, members. So guys, I don't know if in case, remember this is not the official memo, so it's just what I'm thinking. So I don't think there are any stationary points. I'd say nah, there are no stationary points since the graph of the inverse there, since the graph of g prime of x does not have any x-intercept. This is what I'd say, guys. This is what I'd say. So I don't know. We'll see when the official memo comes out. Hopefully you'll go back and refer. So you'll refer back, guys, and yeah, hopefully it will be good. Hopefully, what am I doing now? Let me go back. Hopefully it will be good, guys. Let me do this. Okay. So yeah, let's move on to question 6. Question 6, guys. Question 6, question 6, question 6, question 6, question 6. It says f of x is equal to p of x. Okay, the graph of f of x is equal to p to the power of x plus q, and g of x is equal to mx plus c are drawn. A is the point of intersection between f and g. B, 0 of and negative 3 is the y-intercept of f. E is the x-intercept of g. Okay. Calculate the value of p and q. How can I get p and q? What is p and q? P and q, it is this graph, right? So how can I get p and q? I can say, I'm thinking of simultaneous, of saying, okay, let's use the point A. When you use point A, 4 it is equal to p to the power of 3 dim plus q, right? And then okay. I was almost excited. Okay, I'm having this coordinate. Remember this is the asymptote again. Remember this is the asymptote. So okay, this is what I can get. I'll say first equation. The second equation, I use this point. X is 0 here, y is -3. So I can say -3 is equal to p to the power of 0 plus q. Oh, actually, I can get q very beautiful. Okay, let me start with that one. This one is interesting. Let me start with this one, b. Y is equal to -3 is equal to p to the power of x is 0 plus q. And then -3 is equal to, what is p to the power of 0? Any number to the power of 0, it is 1 plus q. Therefore, I get q to be equal to what? -4. Q cute. And it makes sense, -3, -4, okay? And then I can use this point again and say, okay, now that I know that my graph of f of x is now p to the power of x minus q, I can now say, okay, let me substitute the point of A, which says 4 is equal to p to the power of x, okay, x it is 3, minus q, okay, minus 4, okay? And then when I take this to the other side, it's going to be 8 to the power of p cubed. So I can say, okay, I can express 8 to the power of 3. 2 cubed minus p is equal to p cubed. Therefore, p is equal to 2. You can cube root here, guys, if you're lazy to do your mathematics. Cube root, p is equal to 3. 2 as case. So, okay, we have found that. Then what? Write down the range of f. Range of f, where does your graph of f start? Starts from -4, goes to what? Goes to positive infinity. So you're going to say your graph starts from -4 to infinity. I do not include -4 because it does not touch this an asymptote. Someone might say y should be greater than -4. Still the same thing. The graph of the inverse. Okay, the graph of inverse, guys, the graph g -1, which is the inverse of g, also passes through B. Where is G? G is a straight line. Okay, if G is a straight line, it will have I don't know how to draw it, but it will have, okay, I'm told that it will have a thing that passes through that. Equation that passes through that. So let me just do this. If it passes through this line, it is also a straight line. An inverse of a straight line, it is a straight line, guys. So okay, fine. Then what? They just say determine the equation of G in the form of Y. Okay, the equation of G. Okay, G it's this one. I don't know why they talked about G first. They should have just said determine the high. Okay, then we need to find the coordinate of E first, okay, before we can find that. But how can we find the coordinate of E? E, it is a point on this graph, guys. Point on that graph. So we need to find, okay. This point here, it is, we said this point here, x is 0, y is -3. So if the inverse passes through that point, if the inverse passes through that point, it means now, if this is G prime, so not G prime, G to the power of -1, or G inverse, it means this coordinate If I were to take it to the coordinate of G, which is the inverse, remember, if I have a coordinate on G, when I take that coordinate on G and translate it to the inverse, it's gonna just swap again. So similarly here, if this is 0 and 3, the coordinate here of E is gonna be x is equal to -3 and 0, and it makes sense. It makes sense to be this one. Hence, now they told us, oh, okay, the inverse passes through that point, so that we can take this point, because if you do not have the point of E, there's no way you're going to find the equation. Okay, so you just needed to say E has the coordinate of what? E has the remember, you need to tell examiner -3 and 0. And then I can find now the gradient. Okay, gradient of EA is going to be y 4 minus 0, and then 3 minus -3, which is 6. So it is 2 divided by 3. And then how can I get the equation? I'll just use which point? The easier point, this one. I'm going to say y minus y1 is equal to m into x minus x1. What is y? I, what is okay, cool. This is division. Y minus, I'm using this point E. Y1, it is 0. Gradient, it is 2 divided by 3. X minus plus 3. So it is minus 3, it is plus. So it's going to be just y is equal to 2 divided by 3 x, and then 3 times 3 is going to just be plus 2. So the equation of this one is y, it is equal to 3 divided by 2. 2 divided by 3 plus 2. X plus 2. Fine, yes. Then write down the equation of the inverse. How do I find the inverse? I swap if y it is equal to 2 divided by 3x plus 2. How do I find the inverse? I swap again, and then I take x minus 2 to the other side. This is the same, guys, as saying 2y divided by 3. But I'll just say it is 2 divided by 3y. And then I'll multiply by the reciprocal, 3 divided by 2. What reciprocal? The reciprocal of this one that I'm trying to eliminate, so that this one and this one will cancel. So that this one and this one will cancel, this one and this one will cancel. And then I'll be having y, it is equal to 3 divided by 2x minus 3. So that's the equation, guys. That's that. Okay, if you're struggling with your mathematics here, you can say 2y divided by 3, and then multiply the 3 to the other side. It's going to be 3x minus 6 is equal to 2y. And then you divide everything by 2. This one is going to be divided by 2, divided by 2, divided by 2. It's going to lead to y. It is equal to 3 divided by 2x minus 6 divided by 2 is just 3. So beautiful. Question 7. John invests an amount of money in an account paying interest at a rate of 15% per annum compounded monthly. Calculate the annual effective rate of this investment. Calculate the annual effective rate. It's just easy, guys. When you convert from nominal to effective, you just say 1 plus I effective. It is equal to 1 plus I nominal divided by N or M, whatever you use. I want effective, so I'm just going to say 1 plus I effective. It is equal to 1 plus, it is compounded what? Monthly. So I nominal, it is my interest, 15%, which is 0.15 divided by 12 to the power of 12. N should be the same thereof. And then I just take the 1 to the other side. I effective will therefore equal to what? 1 plus 0.15 divided by 12 to the power of 12, which gives me some, okay, minus 1, which gives me something like 0.16075. And then when I want to convert it to my rate, I just need to multiply that by 100, and then I get my rate to be answer times 100, 16.08% or 0.75. It's fine. Okay. They say to us, Tino invest. They like Tino, guys. Guys, they like Tino. I once did a question about Tino. I think it was November 2023, or if it's not November 2023, it's supposed to be, yeah, it's November 2023. I'm so confident. They talked about Tino. And Tino is that type of guy who likes to invest money and then withdraw it. Ne? So the last time I remember he won jackpot in 2023 question paper, November 2023. You can watch it. I have that video there of he won a jackpot of 1,600,000, and then he invested it into the bank, and then each and every month he withdrew, I think, 20,000. And then they wanted me to calculate how many months will he make withdrawals of 20,000. I think it was something like 78, 170 something there. So let's see this time what happens to Tino. So Tino again invest 500,000. So Tino, guys, is rich in an account earning interest at a rate of 6% per annum, compounded quarterly. Okay, so Tino decides to withdraw 11,250 at the end of every 3 months. Tino will continue making these regular withdrawals until there is no money into the account. So, how many withdrawals of 11,250 will Tino be able to make? Now, this question again, I'll emphasize it. Many students want to take it as what? As a future value, but it's not. Why is it not a future value? Future value it is when you are the one who continuously make payments. You make continuous deposit into the account. But in this case, Tino is not doing deposits, but is rather investing and then withdrawing. So it's like Tino, let's say this is Tino, this is the bank. It's like Tino borrowed the bank 500,000, and the bank needs to pay Tino each and every month, or in this case, it is compounded quarterly. So each and every quarter. So after every 3 months, the bank will pay Tino 11,250 installment. Okay, so Tino borrowed them this much, and the bank will pay back the loan or by 11,250. It's not the case, but it is the similar situation. So how many will he be? And it is compounded quarterly, guys, very important. 6%, okay, every 3 months, sharp. So we need to see it's going to be P, it is equal to X 1 minus 1 plus I to the power of negative N. Why am I using present value? Because it's like Tino is loaning the bank, but it's not the case. It is 500,000. X, it is 11,250, agreed? Yes. And then 1 minus 1 plus, what is I? 0.06. It is my interest. Compounded quarterly. Quarterly it is 4. And then I want to know how many withdrawals is going to make again each and every quarter. So I just divide by my interest, divide by 4. And then it's just a matter of doing mathematics. Just multiply this out. I'm going to say 500,000 multiply by 0.06 divided by 4. The value that I get, it is 7,500 or 7.5. I divide 7,500 by 11,250. I get 2/3. It is equal to what? 1 minus, I'm left with this 1 minus what? 1 plus 0.06 divided by 4. It's 203 divided by 200 to the power of negative n. And then I can take this one to the other side so that it becomes positive. 203, 200 to the power of negative n is equal to 1 minus 2/3 is going to be 1/3. And then negative n is going to be just log of what? Of the base, which is 203 divided by 200. The exponent 1/3. Let's see. I'm gonna get a negative answer. Log of 203 divided by 200 to the power of 1/3. I get negative 73.79. Therefore, n is going to be 73.79. Guys, do not convert this. Do not convert this. So these are the payments. Okay, these are the payments. Okay, withdrawals. He's going to do these times withdrawals. But the question specifically asks us, how many withdrawals of 11,250 will Tino be able to make? Of exactly 11,250. So, since when it is 73.79, it tells you that Tino will make 73 withdrawals of 11,250. What about this 0.79? The 0.79 that is left. It means that Tino will make and one withdrawal of value less than 11,250. This 0.79, it is the last payment, and the last payment will be less than the actual payment because it needs to be a full month or quarter. It needs to be one for you to get what 11,250. But in this case, it is 0.79. So what's important is that Tino will make 73 withdrawals of 11,250. This one is just me explaining to you. Okay. Move on. Question 8. Determine f prime of x using first principle. I so wish I cannot do this question, but I have to. F of x, it is equal to x squared minus 2. I already know the expected answer is 2x. Let's just play with there. F of x plus h. I just want f of x plus h first. It's going to be x plus h to the power of 2 minus 2, which is the same as x squared plus 2xh plus h squared minus 2. Guys, you know how to do this. And then find f of x plus h minus f of x. It's going to be x squared plus 2xh plus h squared minus 2 minus, what is f of x? F of x is x squared minus 2. So the x squared minus 2 will cancel off. Negative 2, negative and negative will be plus. So negative 2 plus this one will cancel off. So what I normally tell my student is that whatever that is on f of x, when you do f of x minus h, it should just go away, all of it. It should not appear. So here I'm going to be left with 2xh plus h squared. And then I can go to my formula and say f prime of x, it is equal to limit as h approaches 0 of what? Of f of x plus h minus f of x, all divided by that by h. And then my limit, remember you continue with limit until you substitute. What is f of x plus h minus f of x? It is what? 2xh plus h squared divided by h. And then I'm going to have limit as h approaches 0. I want to take out h as a common fact. Why? So that I cancel this h. Why do I need to cancel the h? Because if I were to substitute this h in the denominator as 0, it's going to be undefined. So I just try to avoid that. and then I have limit as h approaches 0 of 2x plus h. And then when I substitute it, I'm going to say, therefore, f prime of x is equal to, when I substitute this as 0, it's going to be 2x plus 0, which is just 2x. So we are fine. The answer is perfectly as we have predicted. Guys, first principle is just easy 5 marks that one should be in a position of getting no makanjani. Like, guys, you need to get that. Okay, sorry for being random and singing. Let's move on to differentiation rules, the derivative rules, differentiation rules, where many people do mistakes, guys. All right, I was just hydrating, drinking water. Now I have this one, d dx of 3x squared minus 4x. This is the easiest. Equal sign. Can I now derive this? It is fine to be derived. Therefore, I just drop d dx. So the answer is going to be 2 multiplied by 3, it is 6x. Then 2 minus 1, it is 1. So it's 6x minus 4. And then this one is easy, guys. I'm interested in this one. I have g of x, which is now equal to negative 2 square root of x multiplied by x plus 1 squared. I need to find g prime. Before I do that, I need to make sure I remove the bracket. Remember when I derive, I do not need this. These things, I do not want them. So I have a square root here. I can simplify that. Still, it is still g of x. Remember, if I'm having x to the square root, it's going to be, okay, if I'm having x to the power of and 2 here, it's going to be x to the power of 3 divided by 2. So here it is just 1. And then here, remember, square root it is 2. So it's half. Multiply by, I can simplify this to x squared plus 2x plus 1. And then it's going to be, when I multiply out, it's going to be negative 2. X to the power of half plus 2. This plus 2. Remember, when I multiply the same base, the exponents are adding each other. Half plus 2, it is 3 divided by 2. 5 divided by 2, because it's going to be 2,5. And then minus 2 multiplied by 2, it is 4. And then half multiplied by 1 here, it is 3 divided by 2. Okay. And then minus 2x to the power of half. Am I in a position of deriving? Beautiful. I can now say the derivative is now what? Let me write it a little bit down now. What is 5 divided by 2 multiplied by negative 2? It's going to be what? It's going to be 5, negative 5. Okay. Use your calculator. Negative 2 multiplied by 5 divided by 2, guys. Use the calculator. Do not make yourself a mathematician. Okay. And then 5 divided by 2 minus 1, which is 2,5 minus 1. It is 1,5, which is 3 divided by 2. Minus 3 divided by 2 multiplied by this one, it will be negative 6. Guys, use your calculator. Negative 4 multiplied by 3 divided by 2. Okay, and then 3 divided by 2 minus 1 is going to be just half. Minus half multiplied by 2 is going to be 1. X, half minus 1 is going to be negative half, guys. Get a mark for all this. You get a mark for differentiating this, and that, guys. Very important. I remove this and now move to the tangent question. I think it says to us, given that y is equal to 4x minus 14 is a common tangent to what? To f of x is equal to this, and ax squared blah blah minus 18. Calculate the value of a and b. So this one is a common tangent to both graphs. So this one, 2x squared minus, it is a graph like this. It is positive. It is smiling. It has a positive value of a. It is smiling, and then I have a tangent there that passes through that one, and it has an equation y is equal to 4x minus 14. But it is also this one, I'll name this one f. but it is also a tangent to a very another graph of G, and it has a common what thing there. So here at a common point here. So yeah, they will have. I don't know how it looks like, but I this is just my assumption that it is facing downward. I'll say this is G. Okay. What is it that I always emphasize about a gradient and a what and what? This one here, there is a point here that I'll name P. That point there, it is a common point between F and Y. Okay? It is a common point between F and Y. They share that common. F and Y, F and the tangent Y shares this common point. Also, G and Y share the common point, this one. Okay? So we want to find A and B, basically just finding the equation of G. Let's first start by finding the gradient, the value of X and Y. What do we know? We know that at P, what? F of X is equal to Y. The value of Y for this graph of F, it is exactly equal to the F of Y for this graph of Y. Okay? This is what I know. They share the same Y. If they share the same one, it means now, oh, does it mean that F of X it is equal to Y? Yes. That's the honest truth. So it means now 2x squared minus 4x minus 6, it is equal to equation of the y. The y is what? 4x minus 14. Okay? And then I can try to solve that. Okay, 2x squared minus 14x minus 4x, it is minus 8x. And then negative 6 plus 14, it is 8. So equal to 0. When I take 2 as a common factor, I have x squared minus 4x plus 4 is equal to 0. This one simplifies beautifully to x minus 2, and x minus 2 squared is equal to 0. Therefore, x is equal to 2. So the x coordinate here, where they meet, x is equal to 2. Okay? X it is equal to 2. Now, what is their y? What is their respective y? How can I get y? Y, I can get it by saying, I'll take this equation and say 4 into 2 minus 14. And I get that y is equal to 8 minus 14, it is negative 6. 8 minus 14, it is negative 6. So here is what? Negative 6. Okay. Okay. Now that I have found that point here, there, what is it that I also know about? I also know about this point P is that at point P, f of y, f of x is equal to y. Also, the gradient of f, okay, the derivative of f, it is equal to the gradient of what? Of gradient of the tangent, but at a specific x coordinate. Okay, because when I derive f, it is just the derivative of the whole function. But I know that the gradient of f at this point, it is equal to the gradient of what? Of the tangent. So at x, it is equal to 2. So basically, I mean that f of 2, it is equal to m of gradient. Okay, but I don't need to prove that. Okay, you can prove that by, where is it? By taking the derivative of this one. The derivative, remember, it is 4x squared, 4x minus 4. And check when you put 2 here, it's going to be 4 into 2 minus 4, which gives us 4. Can you see that it is equal to 4, which is the gradient of the equation? But this also means that since, well, it is also a common point for this G, it means now G at x is equal to 2, is going to be equal to the gradient of the tangent, which is equal to 4. The gradient of the tangent, we know it is equal to 4 here. I get so, and another thing that we know that is that g of x, it means it will also equal to y. Okay, if they share the common point, it means the value of y of g here, it is equal to the value of y of the thing here. But we have already used this one. This one we don't need to. We can use this one, information about g, to get the thing there. Let's start with the gradient. The gradient will say, okay, g of 2, it is equal to 4. This 4, remember, it is the what? The gradient of the tangent. Let's see, how can I derive this one? When I derive g of x, it becomes 2ax plus b. Okay, so it's gonna be 2ax plus b is equal to 4. But when x is equal to 2, okay, when x is equal to 2, so it's gonna be 2a into 2 plus b is equal to 4. And then this is just going to be 4a plus b is equal to 4. And then I can say b is equal to what? Negative 4a plus 4. Name this equation 1. And go to the next property. G of y is equal to y. Okay, g of y, it is the value of y. So ax squared, when, okay, again, guys, it is equal when what? Not necessarily this graph, all of this graph, it is equal to when y is equal to 2, the x is equal to that one, is equal to y, and that y we already know it is negative 6. Okay, so that's why we already know it is negative 6. So it means now also here, the value of the graph of this one, the value of y on this graph when x is equal to 2, it will be equal to also what? Negative 6. We have proven that. Okay, so I will say g of 2 is equal to negative 6. What is g of 2? It's just the equation of g substituting x as 2. So it's going to be a 2 squared, x is 2, I square that, plus b 2, then minus 18 again, equal to negative 6. So here I have just 4a plus 2b is equal to negative 16 plus 18 is just 2. Hopefully I did not do any mistake. I did. Here it's negative 6. So negative 6 plus 18, it's just 12. And then I can say this is equation 2. And then let me sub equation 1 into equation 2. And then when I do that, I'll get something like 4a plus 2 into b, it is negative 4a plus 4, which is equal to 12. Simplify that, it is 4a minus 2 multiplied by negative 4, negative 8a plus 8 is equal to 12. And then this means that, where can I continue this? I'll continue to here. 4a minus is negative 4a is equal to 12 minus 8, it is 4. A, it is equal to negative 1. If a is equal to negative 1, how can we find the value of b? Finding the value of b, I say b is equal to negative 4 into negative 1 plus 4, which is 8. So a is equal to negative 1. So a is equal to negative 1 plus 8x minus 18. And it actually makes sense that a is negative. Can you see? When I assumed the graph to be like this, it was the only way they can share a common point. So can you see it is negative like that, guys? So yeah, it's that. It's beautiful. Okay. So the value of a, it is negative 1. The value of b, it is 8. So we are fine. The question is now clear for 6 marks. Question 9. We are almost there, guys. We're almost there. We're almost there with the paper. Question 9. I'm giving that f of x is equal to x cubed minus 6x squared plus 9x minus 4. Okay, they have also factorized it for me, but only one factor I know, x minus k. Show that k is equal to 1. If k is equal to 1, they're trying to say show that 1 is a factor. Okay, if 1 is a factor, it means that if I were to substitute it here, it will give me 0. So let me say f of 1, it is equal to what? 1 cubed minus 6 into 1 squared plus 9 into 1 minus 4. It gives me how much? 1 cubed minus 6 plus 9 minus 4. It gives me 0. Therefore, k is equal to 1 is a factor. Okay, is a factor. So yeah, you just do that. Just show that it is a factor. So it means here I have x minus 4, x minus 1 squared. What do I know about the graph that has a square? It tells me that one of the points is acting as a turning point as well as what? As an x-intercept. Let's look. The value of a here is greater than 0, meaning the last shape will be a happy. So I'm expecting a graph like this. The last shape should be happy again. But now, can we see if the graph is like this? Somewhere here, it's going to be like this, or the x-axis is going to be like this. The question is where? It's going to be when x is equal to 1. When x it is equal to 1, can you see it's going to be x it is equal to 1 or x it is equal to 4. So x it is equal to 1 somewhere here, x it is equal to 4 somewhere there. So it's like this, guys. So my graph is going to be more or less like this. The y-intercept, it is -4. So going to cut at -4. Okay. This is just a demonstration of how my graph is supposed to look like. They did not ask me to draw, but I'm just being ahead of myself. And then they say now, calculate the coordinates of the turning point. What do I know about the turning points, guys? Very easy. The turning points, and can you see, it means this one here, it is also a turning point. So one of the turning points, when I find them, it should be 1. Let's prove that. How do I find the turning point? I need to find my derivative. Should be equal to what? To 0. What is my derivative? 3x squared minus 12x plus 9 is equal to 0. And then I will take out 3 as a common factor. It's going to be x squared minus 4x plus 3. It is equal to 0. Factors is going to be x minus 4, x minus 3, and is lying like this. And then x it is equal to 3 or x it is equal to 1. Already I know that this one was supposed to be a turning point. Why? Because it repeated itself twice here. Remember, this is 1. So when it repeats itself twice, it tells you that it's going to act as a turning point as well as x-intercept. Here, can you see it is 1 there? So we already know that we want the coordinates. We already know that f of 1, when x is equal to 1, y was what? Turning point here, it is 0. It is 0. So I'll be interested in this one. F of 3 is going to be, I'll just substitute there, going to be 3 cubed minus 6 into 3 squared plus 9 into 3 minus 4. Let's see how much I get. And my answer should make sense to the sketch that I thought of, so it will be more negative. Let's see if that's true. That's true. If x is 3 here, it makes sense, okay? It makes sense that x is 3. Let's find y. 3 cubed minus 54. Let me do it manually. 3 cubed minus 6 into 9 plus 27 minus 4. Guys, I get -4. Okay, so it means here, this coordinate here, which is 3 and -4 should match my y-intercept, because my y-intercept is -4. So it means if I were to redraw the graph again, supposed to look like this. Supposed to look like this. And it does not make sense. Let me repeat the process again. It won't make sense to me to be like that. 9, 18, 27 minus 4. I get -4. How is it that -4 is going to match my y-intercept? Maybe I might try to switch that to do. Guys, there's no way, literally no way. Unless I made a mistake somewhere. Let me see. 3 cubed it is 27. So it will just be -54. You guys. Is it negative here? Or it's positive? Okay, 3 cubed. Ne? Minus 6 into 9. Guys. Plus 9. Or let me say 3 squared plus 9 into 3 minus 4. Guys, let me do this manually because I don't know. 27 minus 6 times 9, 54, plus 27 minus 4. Guys, it is like that. Okay, it's -4, fine. So I already know the turning point here. It's supposed to be at 3 and -4. I don't know how I'm going to be able to do that, but it's fine. They say, explain the concavity at x is equal to -3. The concavity at x is equal to -3. Okay, we want to see when x is equal to -3, whether our graph is concave up or concave down. So let's first start by seeing how much is our point of inflection. Our point of inflection is gonna be 2. How do I know? Okay, guys, I see why my graph is not making sense. Supposed to cut here. Since well, all my x values are positive. So this is 1, this is -4. So it can match the -4. Okay, I'll fix that. I can fix that. I'll fix that. They are saying to me, describe the concavity at x is equal to -2. Point of inflection here is going to be 2. How do I know that? Point of inflection is a point between the two x coordinates of my turning point. So point of inflection is going to be x coordinate of the point of inflection going to be 1 plus 3 divided by 2, which is 2. Okay? Okay, yes. But now, you can also use the second derivative, guys. If you know that your first derivative it is equal to 3x squared minus 12x plus 9, you can double derive. When you double derive, you get 6x minus 12. Equate that to 0. You're going to get 6x is equal to 12, then x is equal to 2. Okay, yes. But now we are interested to see how is the concavity when x is equal to -3, somewhere here. Can you see that -3 is going to be on this portion here? So the concavity when x is equal to -3, do you see it's going to be concave down? Because here it is 2, so -3 is just somewhere wherever there, -3. So it is concave down on that interval. So it's going to be concave down. Okay? I don't think you'll get a mark for just saying concave down. You just need to say the x coordinate of point of inflection, it is 2. I get and, okay? I'm going to say x is equal to 2 and it is concave down. for x is less than 2. For x, when x is less than 2, meaning it's going to the left-hand side, it is concave down. Okay, so x is less than 2. Hence, now we are saying it is concave down because uh, x is negative 3. And now, yeah, just leave it there. X is equal to 2, point of inflection, and then it is concave down for x is less than negative 2. It is concave down. So hence now it's going to be concave down. Draw the graph of f, label the points and what I can draw now easily so, a bit. Confidently so. Confidently so, and say y, x. I know here at 1 is going to be my turning point at 1, my turning point also here. So I can just do a demo fan and say this point should be the same as the turning point there. This is fine, guys. Perfectly fine. And then you just need to indicate or here, x it is equal to 1, x it is equal to 4. The coordinate here it is 3, and y it is equal to negative 4. And then you need to indicate that also here it is negative 4. And then you need to tell us that this is the graph of f. And then when you get your full marks and you are beautiful. Done. And then 9.5, calculate the maximum distance between f and h between 1 and 3. Okay, if h of x is equal to negative 2 multiplied by the derivative of f. Okay, let's look first on how the derivative of x would look like. Remember, the derivative of f is just the parabola. Okay, if f is a cubic function, the derivative is going to be a parabola. And how do I know the shape? The shape is going to be looking upwards. But now the points that I need is going to be what? 1, it's going to be my first x-intercept. Okay, and then 3 is going to be my other intercept. So, and then my point of inflection, which is 2, is going to be my what? My turning point here at 2. So my graph is going to be more something like this. This is the graph of f prime, but now it has been multiplied by negative 2. The magnitude does not matter 2, but the negative will have an effect on my graph. How will it have an effect? It will have an effect on my graph because my graph will look upside down. Okay? It will be reflected. It's like we have reflected it across the x-axis. So when you reflect it across the x-axis, it will just turn around, guys. It will just be flip. So we'll just have this instead. We'll have this instead. These points here are going to be flipped like this. Okay? And then that. This is our graph of what? Of that one. And we know that here, the coordinates are still remaining. Remember, the coordinates here are 3. How do I know that it is 3? Remember, when I derive a cubic function, the x-coordinate of my turning point are going to be the x-coordinate of my x-intercept. So I'm having that. So this is what? This is the graph of negative 2 f prime of x, which is h of x, basically. The question is what? Determine the maximum distance. The vertical maximum distance between what? In this interval. So what is the maximum distance? Remember, I can get this one. This is still the distance, distance. So I want a maximum. So I can create an equation for the distance and maximize it. Okay. Let me remember which one is above the other. Can you see that h of x is above? And also the equation for h of x is going to be negative 2 multiplied by f prime. F prime is just the derivative, which is just 3x cubed minus 12x No, sorry, I meant to say 3x squared minus 12x plus 9, which is going to be negative 6x squared plus 24x minus 18. So this is just our graph. So remember, this one is at the top, at the bottom. So the maximum distance is going to be distance with respect to x. I can say distance with respect to x is going to be h of x minus f of x. What is h of x? H of x, we just saw it is what? Negative x squared, 6x squared, plus 24x minus 18 minus f of x, 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 original graph. I need to say minus and then x cubed. X cubed minus 6x squared. I continuously check it so that I do not make any mistake. Plus 9x minus 4. So I can now become a mathematician and say it's going to be negative x cubed, okay? And then negative 6x squared plus 6x squared. Can you see? It's going to be negative plus, it's going to be positive, okay? It's just going to be negative plus positive will cancel off. And then 24 minus, because negative by positive is minus. So 24 minus 15, minus 9 is 15, guys. Then negative 8 plus this one, it is 22. Okay, negative 18, negative 18 plus 4, guys, it is negative 14. I'm sorry, it is negative 14. This is the equation of ha. Let me see. It's the first time having this one. Okay, it's fine. Guys, let's just continue. And then for me to maximize this, I need to take the derivative and equate it to 0. Remember, for you to maximize something, you need to take the derivative and equate it to 0. What is the derivative of this one? The derivative of this one is going to be negative 3x squared plus 15. It is equal to 0. And then, can I simplify this any further, guys? I can. X squared is going to be equal to negative 15 divided by negative 3, which is 5 at home. 5. And then x is going to be equal to plus or minus 5. But remember, they told me it should be in a region between, not just 5, guys. Square root of 5. How much is square root of 5 then? Square root of 5. Square root of 5, it is 2,2, blah, blah, blah. So yeah, it makes sense because it is between there. Okay, hopefully I did not make any mistake. So I want the value of the maximum distance when x is between, they told me that when x it is between 1 and 3. So between 1 and 3, it should be positive. So for me to find the maximum distance, I'll come here and say d of square root of 5. Okay, because negative square root of 5, it is not between 1 and 3. So d of square root of 5, I come to this equation here. I say negative square root of 5 cubed plus 15 square root of 5 minus 14. Oh, and see how much you get, guys. I don't think it's a beautiful number. I don't think it's a beautiful number. Cubed plus 15 into square root of 5 minus 14. So we get a number that is something like 8,36 units. Hopefully I did not make any mistake, but yeah, I think, let me just confirm again here, negative 2, the derivative of this one. Okay. 3x squared minus 12x Let me remove this. 3x squared minus 12, 3x squared minus 12x plus 9. Okay, sharp. And then I just multiply that by 2, negative 6x squared plus 24 minus 18. Oh, it's sharp. Everything is fine, guys. So yeah, the answer it is this one, 18.36. Guys, you are allowed to correct me when the memo officially comes out and say, okay, you made a mistake here, blah blah blah. And I'll also look out for that and then try to edit the video if I can. Remember, this is not an official memo, it's just the prediction. Question 10, probability question. If A and B are mutually exclusive events, if probability, okay, A and B are mutually exclusive events, A and B, probability of A is this, probability of A or B is that, calculate the probability of B. This one question is always, it always appears, guys, and it's the easiest. What do they mean that the events are mutually exclusive? It means that the probability of A and B, it is equal to 0. It means now my events are like this. This is what, for A and B, this is what we refer by mutually exclusive events. So how can I find probability of B? Remember the general equation or the general formula says probability of A or B, it is equal to probability of A plus probability of B minus probability of A and B. But in this case, it is equal to what? 0. So it just goes off to 0. And then I can substitute what I have. Probability of A or B, 0.79. Probability of A, 0.42 plus probability of B. And then, guys, probability of B will be equal to 0.35. 37. Nice. Okay. Oh, let's look at this one. Ooh, what's happening here? A game at Fun Park requires a player to roll a 6-sided dice and pick a card from a deck of 52 cards. Okay. A player wins if an odd number appears on the uppermost face of the dice. Okay. And the player draws a picture card from the deck. Okay. Okay. Oh, okay. Let me repeat the statement. A player if wins if an odd number appears, okay, on the face of the dice, and then the player also draws a picture card from the deck. A picture card from the deck. Okay. So I'm having this. It's it. I'm gonna come to this one. I'm gonna come to this one. So this is a tree diagram. So it's either when a player rolls a die, when a player roll a dice, it's either it is odd or it is even. Okay. The chances that it is odd, remember, a dice is made up of 6 numbers: 1, 2, 3, 4, 5, 6, of which 1, 2, 3 are odd. 1, 3, 5 are odd. Okay. So 3 out of 6 cards are odd, and then 3 out of 6 dice. So 6 dice are even. Not dice is actual dice, but the number. Okay. The number. Okay. Is the number that is even, the off. And they tell you that for this particular person to win, you need to do what? To if a player wins if an odd number appears in the uppermost face of the dice, and the player also draws a picture from the deck. Okay, draws a picture from the deck. So how many decks do we have? So we have 4 decks, ne? And then on the 4 decks there are 4 pictures. So for you to win, you need to take to draw a picture card as well as from the deck. So we have 4 decks. The 4 decks are these decks. Okay, I do not know cards, but it's going to be something like this. Let me try to illustrate that. So it's going to be the hearts, the diamonds, the spade, this is not the diamond. The spade, I think the spade it is something like this. And then and clubs. I don't know how to represent clubs, guys. And clubs. I'll just say clubs in here. There are 4 pictures card: king, queen, jack, and ace. So on this deck card, the picture can either be what? The picture, the what? Yes, the picture on each deck card can either be king, queen, jack, or ace. Also here, it can either be king, queen, jack, and ace for all of them. King, queen, jack, and ace. King, queen, jack, and ace. So now, what is the probability of that person now choosing winning a game? So for you to win a game, you need to have probability between these two. So it means now the chances of choosing a deck with a deck with a picture, the probability of choosing of a player drawing a picture card from a deck, it is what? So it is going to be 4 multiplied by 4 multiplied by 4. So it's basically this plus this plus this plus this. So it's just basically these decks, these pictures, which are 4, multiplied by the number of decks, which is 4, which is 16. So there are 16 possible ways, or you can add this plus this plus this plus this. So there are 16 ways. If you want to win, for you to win, you need to choose a what? A picture card. Okay, let me say a picture deck, or it's either you choose a picture deck or non-picture deck. I don't know if I put it nicely here. Also, you can also do the same here. We don't need that because they are talking about for you to win, you need an even. So remember we said for you to, probability of you choosing a picture deck, it is 16. Out of how many cards do we have? 52 cards, out of 52 cards. And then non-picture is going to be just, if this is 16, then it's going to be 52 minus 16. It's just 36 divided by 52. Also here, it's the same, guys. 16 divided by 32. 36 divided by 52, not 32. Here it's either is picture deck or not picture deck. Then they tell me that for you to win, I'm going to come back to this statement, guys. For now, I'm not there. For you to win, okay, for you to win, a player wins if an odd number appears on the upper most face of the dice, okay, when you, the odd, and what? And a player draws a picture card from the deck. Picture card from the deck. So a picture card from the deck. You win when you have the probability of these two. Odd multiplied by picture deck. This is the probability of you winning, which is 3 divided by 6 multiplied by 16 divided by 52. This is the chance of winning, the probability of winning. It is this one. Okay, if you have done this, you have won. Now we move on. It says a player pays 10 rand to play a game, and okay, a player pays 10 rand to play a game in an hour. Okay, and then 260 people can each play one game. Okay, if the owner wants to make 70% profit per hour, calculate the maximum amount that the owner must make out to reach the win. Okay, so calculate the maximum amount that the owner must pay out to each winner. Okay, so now let's go to that statement. Revenue. Okay, revenue, it is now the amount, the amount that the what the owner will have for each participant. Okay, for each participant, it is the revenue or the amount that the okay, owner's amount or the amount paid. Okay, let me say amount paid by each player. So each player pays 10 rand, and how many players are there? 160. So the amount paid, it is 206 multiplied by 10. So 2,600. So this is the amount that the owner will have. Okay, the owner will have. The owner will have this money. But now we are told that the owner wants to make 70% profit per hour. So the owner wants to make a profit of 70%. Profit of 70%. And then where is the other 30%? The other 30%, it goes to the what? To the winner. Okay, to the winners, basically. Okay. So they say calculate the maximum amount that the owner must pay out to each winner so that he makes a profit of 70%. So it means the winners will share 30% of this amount. Let's have 30% of this amount. 30% of this amount. 30% of that amount, it is 780. 780. So this is the amount that the winners will share. Okay, this is the amount that the winners will share. Now we need to know how many winners do we have. Okay, this is the amount shared. Now we need to know the number of winners. How many winners do we have? What is the number of winners is going to be 260 players multiplied by the chance of winning. What is the chance of winning? The chance of winning, you will win only if you have this one. Okay, so these are the chance of winning. What are the chance of winning? The chance of winning will be 3 divided by 6 multiplied by what? 16 divided by 52. So this is the probability of a player winning. Okay, and how many players are there? There are 260 players. So how many players, number of players or number of winners do we have? I'm going to say it is 260 multiplied by 3 divided by 6 multiplied by 16 divided by 52. I don't know how much I get here. I get 40. So exactly 40 winners. So the question is, what is the maximum amount that the owner must pay to each winner? So if there are 40 winners, and this is the amount shared by winners, so the maximum amount by each winner is going to be now equal to what? The amount, it is 780 divided by those 40 winners. We get what? 780 divided by 40 winners. Then this is how much each winner can get. 19 rand point 5. I mean, it's fair to win 19 rand point 5 because you only contributed by how much? By 10 rand, because the owner wants to keep 70% as a profit. So can you see? Actually, this one you did not necessarily need to draw because there's no winner here. The minute you choose an even, then you are out. Okay. You cannot win. So yeah, that's that, guys. So the maximum that they can get is 19 rand, 5 rand. Guys, this is how I have thought of this question. If it is wrong, it's fine. Remember, there is no official memo, but I'm trying to bring all the experience that I have into this question. So yeah, let's move on again. The last question of the day. Last question of the day. Consider the tree diagram. Consider the three-digit number from 501 up to 999. How many of these three digits have exactly one? Okay, how many of these digits, okay, between 501, not between, from 501 to 999, have what? Have exactly 1 5 in them. Oh, okay, so how can a code have 1 5? A code can have 1 5 if 5 starts here. Okay, if 5 starts here, or 5 is here, 5 is placed on the second position, or when there is 5 on the last position. Okay, but now we only want these to have what? To have exactly 1 5 in them. So if I have digits 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. These are the digits that I have, right? 10 digits. Okay. So now for this one, I can have any digit except for 5. So I can have any digit 1, 2, 3, 4, 6, 7, 8, 9, and 0. Okay, I can have as many these digits 1, 2, 3, 4, 5, 6, 7, 8, 0, blah blah blah. Also, and I can repeat. Okay, digits can be repeated. Digits can be repeated, but except for 5. Why except for 5? Because I want my code to have exactly 1 5. So if I have 1 5 here, 1 5 here, can you see this one's here fighting for the position? There's no 5 fighting for that position. So on this one also I can have what? 1, 2, 3, 4, 5, 6, 7, not 5, 6, 7, 8, 9, 0. So here I have one digit fighting for this position. How many digits fight for this position? 1, 2, 3, 4, 5, 6, 7, 8. Fighting for this position, 8 also. Let's consider the second one. The second one, fighting for the second position. Okay, if this one is only 5, it means it is 1. But on this one, it's very important to look at the restrictions thereof. It starts from 501 to 01. 501. So it means the value here, the value here, the value here should be what? The value here can either be 5, but since 5 it is used here, so it means the values here can be 5, 6, 7, 8, or 9, not 0. It is less. If I put 0 here, it will not follow this condition that it from 501. But I need to take out 5. Why do I need to take out 5? Because I have already used 5 here and I cannot repeat 5 because I want only 1 5. Oh, okay, it's fine. So it means I'm only having 4. And then on this one, I can have 0, 1, 2, 3, 4, 5, not 5, 6, 7, 8, 9. So I can have all, guys, this is not 8, it is 9. 9 here, 9 here. Okay, and then here fighting for this position, can you see there are 4 of them? And then fighting for this position, there are 9 of them. Okay, and then also here it is 1. Here, also here, the values fighting here, it can either be 5, 5 cannot be 5, because we already have 5 in there. So it can either be 6, 7, 8, 9. Here it can be any value except 5, 0, 1, 2, 3, 4, 6, 7, 8, 9. So here there are 9 values, here there are 4 values. So I hope it's clear. So how many digits? Number of digits that you can do is going to be equal to what? The first one, it is 1 times 9 times 9, plus the second one can be 4 times 1 times 9. But can you see this one? It is just the same as that one, but I'll just add it. 4 times 1, 4 times 9 times 1. It gives me something like 1 times, 81 multiplied by 86 squared. Oh, I'm lying, guys. 81 plus 36 squared. Ish. And let me repeat again. 9 times 9 plus 4 times 9. I'm going to repeat twice. Okay, I now get a number that is 153. So there are these digits. But I want you to take note of something, guys. If this number was to be 0 here, let me erase this. If this number was to be 0 here, it's going to be 50, and this number was to be 0 here, the code will be 500, and that will not happen. Why will it not happen? Because it should start from 501. So I should take out this option, one thingy, that is 500. So I should take out 500 as a code. So I should subtract 1. Okay, I need to subtract what? 1. Therefore, number of digits excluding, guys, 500 as a code is going to be 153 minus 1, which is 152. So these are the number of things. Here, can you see? We could also consider this one. Okay, if I have this part, if 0 can also be here and here, it will also affect my what? My results thereof. Let me see if here it can affect. I don't think it can affect here, because it can end with 9, and yeah, it can end with 9, and there's no way it's going to be more than 999. No way. So yeah, but now the question is, how many of these digits? Okay, we have found that there are 152 digits, and then it says 1.1.2. Remember, this was 1.1.1, 11.1 rather. 11.2 says calculate the probability of a three-digit number not satisfying the condition given below. So the probability that it does not satisfy the condition, okay, this satisfies the condition, okay? This satisfies the condition. So we need to find the total number of what? Of probabilities. So the total number of probabilities here from 501 to 999 is going to be, how can I find the probability? The total probability, okay? Or the probability, it will just be the total. The total, what is the total of these? I can have, if it does not meet the condition, I can have all the nine values together like that. I think I can all have the 9 values like that, because I can either start with any value here, start any value here, and then I think there are 10 digits. 10 times 10 times 10, which is 1000. I think, let me quickly confirm that with my calculations here, or calculate the probability of a digit number not satisfying the condition. Not satisfying the condition. Okay, what I can do here, I can say, okay, I can take this as sigma. What do I mean take this as sigma? Let me erase this, guys. What do I mean take this as sigma? I can do this. I can say here, remember in a series, we are saying a sigma might start from, you can say, it starts from 501 and ends, okay, it ends at 999, okay, 999, and it ends at 5, it starts at 501 of whatever thing they're of. Okay, so how can I get the number of terms that are that are there? Remember, for me to get the number of terms, I need to say what? Top minus bottom plus 1. How much do I get? Top minus bottom plus 1. Where's my calculator? 999 minus 501 plus 1. I get 499. So there are 499 total numbers. Okay. So the total numbers, I'm not even going back. The total numbers, is it numbers? Yeah, total numbers that I have there. How many numbers do I have in that? I have 499 numbers. And of the 499 numbers, only 152 satisfy the condition. So which one do not satisfy the condition? Not satisfying, satisfying the condition is going to be 499 minus what? Minus 152 that is satisfying. And then I get that the ones that are not satisfying, they are 340, 347. And if they are 347 like that, they want the what? The probability that is not satisfying the condition. So probability not satisfying the condition gonna be 347 divided by the total digits that I can have, which is 499, which is basically how much? 374, but 347 divided by 499 gives me something like 0.695, or you can say 0.7. That is that, guys. That is that for the question paper for November 2025. I'm lying. February 2020. May, June 2025, guys. This is how I think of the memo. This is how I could have wrote. I'll be aware of when the memo has come out, and then, yeah, officially you will be my judge on how I would have done on the question paper. So thank you very much, guys. I repeat, very important. This is not the official memo. Okay? It's just a what? I don't know. Possible memo. This is just a possible memo, guys. Okay. So thank you very much, guys. It was a long video. I hope it was worth it. Bye.